series on Flutter app development. What is Flutter? It is an open source user interface software development kit, or SDK, created and supported by Google. Why Flutter? Think about this. You can write your code once and it runs on every major platform. That's the power of Flutter. It is a Google UI toolkit that allows for a single code base across all devices. Flutter's core promise is that single code base that can deliver native performance to all devices. It compiles your code down to native instructions, ensuring the speed and look that users expect on any device, whether it's iOS, Android, or a web interface itself. To start this journey, we need three key pieces of software. The Flutter SDK. This is the core engine which includes the Dart language. Android Studio or any other IDE of your preference, or you can use a software like Visual Studio Code to follow along. But personally, throughout this series, we will be using Android Studio. It gives us powerful tools for mobile development. Lastly, you will require a device to run our app on. I personally will be using a physical device, but you can set up a virtual Android device within Android Studio itself. Now, to begin, we need to install the Flutter SDK. Let's do that now. Now that we've looked at Flutter, we will now proceed to install the SDK. You need to do a few things before installing the Flutter SDK. Follow this link in the description to the Flutter SDK manual installation documentation. You need to download some prerequisite softwares to be able to run Flutter on your system. The first software that you need is Git for Windows. You can follow this link that takes you this tab, and you can click on Install for Windows and install this. This is a version control system that will help out with your project. The next thing that we need to set up is an editor or an IDE. As I mentioned before, we will be using Android Studio for the purposes of this series. So I want you to head over to Developer Android and get the Android Studio Auto 2 feature drop. After installing this and installing the Git, we can finally set up Flutter. To set up Flutter SDK, you will need to install a zip file. This is the Flutter Windows stable zip file. This will have the latest version. Download this and extract it to a location that you can access later. Now, once you've downloaded and extracted your SDK into a folder, you'll have a folder that looks something like this. This is your Flutter SDK. Make sure to keep this in a safe location and not delete it. Make sure that there's no white spaces in the name of your folder. So mine is in D drive under development folder, Flutter SDK. As you can see, there's no white spaces. By white spaces, I mean this is a white space. There's no gaps in between your Flutter path. So now, the next step that we need to take is to add this bin folder into the environment variable of the system. What that will do is make your Flutter accessible throughout your system. So for that, first of all, open environment variables. On this panel, you can click environment variables. You will see two sections. One is for user variables and one is for system variables. We will be editing the path of system variables. As you can see, I've already added my path to the system variable, but to add this, click on new. You will get a blank field text. You'll put the path of your bin folder into this. To get your path, click on your address bar and copy this. For copying this, create new, you paste it, and you click on OK. After you hit OK, your Flutter SDK should be added to the path. To check if your Flutter is working, open the terminal. And in your terminal, you want to run Flutter Doctor. This might take a while to run on your first attempt. So Flutter has informed me that there's a new version available, so I will be running the Flutter upgrade. I'll run Flutter upgrade to upgrade my Flutter. But as you can see here, I have Flutter stable channel installed. I have a proper Windows version. I have an Android toolchain that I need to develop applications for Android. I do not have a Chrome browser, but that is only to develop for the web. We will not be doing that, so we won't require this. And I don't have Visual Studio because I will not be developing Windows applications. You can download these two, but for the purposes of this series, we won't be requiring them. I have a connected device and we have proper network resources to run the Flutter SDK. I'll upgrade my Flutter, but this is all you will require to proceed with the series. Now that we have all the software that we need and we've set up our Flutter SDK successfully, we've added it to the path, you can open up Android Studio. When you first open up your Android Studio, it will not look like this. You will not have this icon called New Flutter Project. You need to do some setting up to your Android Studio. Firstly, open Settings. In Settings, go to the Languages and Frameworks Android SDK. Make sure you have an API level 36 installed. You can go to SDK Tools and make sure you have all these tools installed, especially this Android SDK command line tools. You can choose your Android SDK location here. This will be your location that you chose while installing Android Studio. After all of this is done, click on OK. Now, to add your plugins, click on Plugins on the left icon and make sure that you've installed Flutter and Dart plugin. Go to Marketplace, search for Flutter, and install it. Once it's installed, Android Studio will ask you to restart your IDE. Do that, then you can see the new Flutter project icon here. We will go ahead and create a new project for now. Your Flutter SDK path should be the path that you installed your Flutter SDK, you extracted your Flutter SDK in. So I've extracted it over here in Development Flutter SDK. So I will select this folder. Click on Next. You can name your project. I will be naming it my I will be naming my project my first project. Make sure you're using underscores while naming your project. You can give it a description, first project. Remember, all of this is applicable to amends in the future. You can keep an organization URL, but this is just for exporting your package. You will need this while after your project has been completed. I will leave it at default for now. We will not change the Android language, but we're making this app only for Android and iOS, so I will unselect all the other systems. Click on Create. Android Studio will go ahead and create your Flutter project. You can close out of this README tab. Let's direct our attention to the left side. This is your project manager. This is where all of your files are sitting. The main folder that we need to look right now is the lib folder. The lib folder contains all your main Dart files. Remember, Dart is the programming language that Flutter is made up of. This is your main Dart file where the program first looks for the code to execute. I'm sure this looks all daunting at first, but do not worry, we will learn all about this in the future. For now, let's try running this Dart file. So you can do this a couple of ways. The way I'm going to do it is I have a physical device connected to my laptop. So I'm going to run this file in my physical device. The first thing that you need to do to be able to do this is enable developer mode on your device. Please look through the specifications on your specific device. And you need to enable USB debugging and install if you're on Android. So to check if I have successfully connected my device, what I can do is I can search for Flutter devices. This will list all the devices that Flutter has access to. This is my mobile device that I'll be using. It's an Android with version 14 that has a API level of 30. I'll be running this project on this device. Up here, you can select your device, you can select your file, and you hit this run button. This run button will now start a Gradle task that will install this application into your device for a demo run. You can view the progress on your device by clicking on Running Devices. You can add your device and you can see your connected device here. Obviously, you'll have your physical device with you, but throughout this series, I will be using this screen to show you how my device screen looks like. You will now get a prompt. You might get a prompt on your device that asks you to install the application via USB. Click on Install. Your application has successfully been installed and run on your local device. You can make changes to this Dart file which will be reflective on your device here. For example, Flutter gives you a default application that is a counter. So if you press this button here, it will show you how many times you push this button. You can restart this application by stopping it and restarting it, or you can click on the Run tab and you can click this Flutter Hot Restart, or you can use the Flutter Hot Reload. We will be learning about the hot restart and hot reload in the future, but just for now, make sure that you remember these are the three ways that you can restart your application. We've made it to the end of the episode. In this episode, we installed Flutter and configured essential tools in Android Studio. We also successfully ran our first app in our local device. In the next video, we will be learning all about Dart Essentials. We'll be linking different programming languages as reference to learn about variables, functions, lists, and classes. See you there. Hello and welcome back to the Flutter series. This is the second episode. In the first episode, we set up our coding environment. We now have our IDE, we have our SDK, and we can run an app. But we haven't actually learned the language that controls it all. That's where Dart comes in. Dart is the language which we use to code Flutter UI. Today we will dive into core concepts of Dart that you need to start building Flutter UIs. We're going to start by directly going to the compiler and firstly learning about variables and data types in Dart. I've opened up an online compiler for Dart programming where we can run simulation code for Dart. The first thing that we need to learn is variables and data types. But before we do that, let me just explain what we have on the screen here. This is the void main function. So there's two keywords here. There's void and there's main. Main is a function that Dart looks for every time it tries to run a program. So whatever your program has, everything needs to be inside the main function. If you have anything outside the main function, and if it's not being called, then that code will not be executed. So everything that you code will be inside the main function, or the main function will be calling another function. The keyword void refers to a non-returning function. This basically says that we're not expecting main to give any output. So the main does not return anything. Everything executes inside main and everything finishes inside main. Now that's out of the way, let's start with variables. If you're familiar with programming, you know that a variable is simply a container that holds a piece of information. Dart is what we call a strongly typed programming language. This basically means that for every variable that you create, you have to explicitly mention its data type. If you want to create a variable called name and store the value of Flutter, this is not allowed because you haven't explicitly mentioned the data type that name is. If I explicitly mention the data type string, then it allows me to store the value Flutter inside the variable name. There's a load of variable types in Flutter, but the four main ones that we're looking at today is string, int, double, double, and boolean. So let's go by this one by one. An int stores a whole number, an integer. So version is a variable with the data type int that has the value
whole number 4. A double stores a floating point value. So rating is a variable with the value 4.7 assigned to it with the data type double. Bool basically means Boolean values. It's either true or it's false. Now, currently, if we run this program, we're not going to get any output because we're not actually printing anything. Now, to actually get an output, you have to run a print statement. Print statement is pretty basic in Dart. You can simply type print and type in the name of the variable that you want to print. So if I type in print name, it's going to give me Flutter. You can use multiple print statements. If I type in print version, it's going to give me Flutter, and then it's in the next line, it's going to print 4. Now remember that a string variable has to always be in a double quotation. An int is for whole numbers, a double is for floating point, and bool is for binary decisions, or true or false decisions. Now, there's another keyword that you can use to declare variables, and that's the var keyword. There's some advantages to using the var keyword. A var keyword is a globally scoped variable. Now we will talk about what globally scoped variables are once we start with Flutter, but for now understand that it can be accessed throughout the file. The way that you can declare a variable using var is you type the keyword var and then the name of the variable. So let's say language. Now you can directly assign a value while initializing the variable or declaring the variable. So if I say Dart here, this variable now holds a string data type. So this variable is now converted into a string data type. If I try to print this, if I try to print language, it will return Dart. But what that means now is that if I try to assign another data type to this variable, this will no longer be allowed. This will say a value of type int can't be assigned to a variable of type string, because this variable already has the data type string. But we can overcome that by simply declaring the variable. Now, we're declaring the variable, but we're not assigning any value, so this variable is not initialized. To assign a value, you can simply assign a value. I am now assigning a value of int. 5 is a whole number, so language is now holding an integer value. But this value can change throughout the program. So if I now assign it Dart, it will now hold the value of Dart, and this variable changes into a string data type. That's something interesting about Dart programming language.
Let's have a look at functions. For example, if I want to create a function that adds two numbers, I'll simply start by giving the function its name, small braces or parentheses to specify the parameters. So I'm expecting two numbers, a and b. Give curly braces to define the function body. Inside the function body, I want to perform some kind of operation with these variables that are passed into the function. For the purpose of this function, I want to return a plus b. Note that I use the keyword return. This means that when I call this function, I'm expecting something in return. For this instance, I'm assuming that a and b are integers. So adding a plus b will give me an integer value. So I can give a data type to the function itself. This isn't required, however, it is good practice to always know what kind of data type you expect your function to return. Now I can call this function. I can call this function directly by printing it, but there's a much better way to do it. Instead, I'll store it in a variable c. I'll create a variable c, call the function, pass 2 and 3 as arguments, and this will call this function. This 2 will be stored in a, and this 3 will be stored in b. The function returns a plus b, which is an integer value, which comes over here.
Now it stores that into the left-hand side variable, which is C. Now we have an error here because we're not actually defining the data type of C. Now that we define the data type of C as int, we now expect integer value from this function and store it as int into this variable. Now we can print C, and the output will be 2 plus 3, which is 5. There we go. Similarly, we can create functions that work with strings, for example. If I give it a name, and if I change the function's name to, let's say, greet, let's leave that int for now. Now, if I want to return, so what I want this function to do is, if I give it a name, I want it to say hello name. So if I give it Flutter, I want it to say hello Flutter. There's two ways we can do this. We can do this by concatenating strings, which means I can return hello plus name. Now there's an error here because I'm returning a string, but this function expects a return of int. So if I change this to string, it will now be accepted. So this will work as is. For example, now if I directly print greet, and if I pass in Flutter, this function will return hello Flutter. Now, what is actually happening here? Inside the print method, we're calling the greet function. When the greet function is called, it takes a parameter of name. I'm passing an argument Flutter into the parameter name. It now returns hello plus the name that I passed. It returns a string data type, and it gets stored in place of this. So now in place of greet Flutter, hello Flutter gets stored, and the print function prints that. This is one of the methods to do this, but what if you want multiple variables throughout your string? It's not very efficient to keep adding plus variable plus variable plus variable. So instead of that, what we do is variable interpolation or variable extension. We can simply add the variable inside the string quotation itself by using a $sign and two curly braces and type in the variable name. What this does is it replaces this whole expression with the value of the variable. So now I print greet start. It will print hello start. Right. So this is returning function. These are examples for returning functions. We can also create a void function. Let's create a function called greet. So I can create a function called greet. I don't want any arguments passed into this, so I won't give any parameters, and I just want to print hello world. Now, Darts will actually let you declare this function without having a data type. So this is a perfectly valid function, and if you call greet, then it will print, oops, if you call greet, then it will print hello world, but you get null. So the reason why you get this null is because when you call greet, you're expecting an output. You're expecting a value to be returned when you call this function because you haven't explicitly mentioned that this function does not return any value. And when you're expecting a return and look at this function, it's not returning anything, so it shows null because nothing has been returned. So to avoid this, you put void. The void keyword lets you know that this function, when called, will not return anything. So you print greet as is. You just call greet. You don't need to print it. When I was trying to print it, it was trying to get a value from greet, and it couldn't, so it showed me null. Now, when I just call greet without printing it, it will give me hello world. And since this is a void data type, I'm not expecting anything in return. Remember, you cannot create a variable, for example, you cannot create a variable called string and store greet in it because greet does not actually return anything, so there is nothing to store. That's for the void data type in Dart. Now let's talk about control flow statements. Control flow is how we tell the program what to do under different circumstances. We can use if-else for branching logic. For example, let me create a variable called int version equals to 4. Now, I can create a control flow statement to check and compare this version variable to different conditions and output or carry out different tasks based on those conditions. So, for example, if the version is below 5, I want to print version below 5, and if the version is below above 5, then I want to print version above 5. For that, I would do if statement, parenthesis, and the condition. So if my version is below or equal to 4, below 5, I will print version is below 5 and semicolon. Else, print version is above 5. If I run this code now, this will print version is below 5 because my version is 4, which falls under this condition. If I, for example, change this to 10, then the program will check if the version is below 5. This will return false, so it will go below the if statement block, below this block. It will enter the else block and it will print version is above 5. You can use conditional statements in such a way. Let's talk about loops next. So sometimes a problem arises. You want to print something multiple times. For example, if I want to print hello world 5 times, one way you could do that is write hello world 5 times. This will work. This will print hello world 5 times. It does work, but it's highly inefficient. What if you want to print it 1,000,000 times, or let's say 100 times? It's very inefficient. For this purpose, we use loops. So loops in Dart are very similar to loops in JavaScript. To start a for loop is a type of loop that you use when you know the condition. So you know how many times the loop is gonna run, so you use a for loop. For I equals to 0. This is our looping variable. This variable is going to change throughout the loop and it will be checked against a condition. When the condition is met, the loop will exit. I below, let's say 5, and I plus plus. So let's see what we're doing here. We have a variable I which has the initial value of 0. We're checking if I is below 5. So if the value of I is below 5, your program will enter this for loop code. But if your value of I is above 5 or equal to 5, this condition will be false, hence it will exit this block of code. At the end of the iteration, what we want to do is I++. This means that use the current value of I and then increment it by 1. So the next time this loop runs, the value of I will be 1. And then the next time it will be 2, 3, 4, and so on. Now, the reason why we're getting this error is because we haven't actually declared I. So I can declare I by doing int I. Now, inside the for loop, you can add a code that you want to run multiple times. In our case, I'll be printing hello world. When I run this, I will get hello world printed 5 times. The first time I is 0. The second time I is 1, 2, 3, 4. When the value of I is 5, this condition is false, so it exits the loop. So this is 5 times. Hence the loop runs 5 times. We will be using for loop constantly in Flutter to automatically create visual elements for every item in a list. A class is a blueprint or template for creating objects. It defines the properties such as attributes and data, and behaviors, which are methods and functions, that all objects of that class will share.
The class in Dart and Flutter can be understood by using the house blueprint analogy. Imagine a class as a detailed architectural blueprint for a house. This blueprint defines what the house must have, but it isn't an actual physical representation of the house that you can live in. It's just a template that you use to make a house. An object or instance is the physical house built from that specific blueprint. Each house is unique. House number 1 might be blue, house number 2 might be red, even though they came from the same blueprint. The same blueprint can be used and reused multiple times to create different instances or objects. While creating a new object or an instance, you need to define some basic properties, such as its name, its foundation, its address, its color. These properties are defined in the constructor of the class. It is a required initial step that ensures every new house or every new object is built with essential starting specifications before it can be considered complete. These may be changed later throughout the program, but they need to have initial values to begin with.
A class is a blueprint used to create objects. It defines what data or variables and actions or methods an object will have. In Dart, everything revolves around classes and objects. So let me explain what a class is by a practical example. First of all, we'll create a class called person. To do that, I will use the keyword class in combination with the name person. Notice that the class name has to be written in Pascal case, which basically means the first letter has to be capitalized. Class is the keyword used to define a class. I'll create variables name and age inside the class. So name and age. These are two properties that I expect a person to have. A name should be of data type string and age should be of data type int. These are called instance variables. Every object that I create using this class will have its own copy of name and age. It will have its own unique name and age. A string stores text, an integer stores numbers. Now, a constructor. Every class needs to have a constructor. A constructor looks like this. It will have the name of the class, and in parentheses, it will have this dot the two variable names. So this dot name and this dot age. So, what is a constructor? A constructor runs automatically when an object is created. A constructor name must match the class name. This dot name refers to this variable inside the class, and this dot age refers to this variable inside the class. Parameters name and age receive values from the outside. So when you're creating a new object, you have to pass in name and you have to pass in age. This keyword lets it know that the name and age that you passed in is specific to that object. Class can have behaviors or methods. Behaviors and methods are basically what you expect an object of that class to do. I want a method called greet. So I can create a method. We learned how to do this. I can create a method. It's called void because I don't expect it to return anything. And inside, I just want to greet. So name is age years old. So let me explain this. Void is a method that returns nothing. Greet is a behavior of the object. It uses object's own data, name, and age to achieve something. To finally create an object using this blueprint class. To create an object, you put the class name, you put the variable name, and then you call constructor. In the class constructor, you need to pass two things. You need to pass a name, you need to pass an age. So I'll pass Flutter for the name and 21 for the age. What's happening here? Person creates an object. The constructor runs and assigns values. So it takes Flutter and assigns it to name. It takes 21 and assigns it to age. P1 stores a reference to the object. So P1 stores a reference to the newly created object. I can call the greet function inside P1 object by doing P1 greet. So what this does is it calls this method for this object. So if I run this, it'll print Flutter is 21 years old. Name is age years old. Let's create a new class called student. Class student. I expect the student to have some properties. So I expect the student to have a name, an age, and a college that they study in. The name should be of the data type string, the age should be of the data type int, and the college should also be of the data type string. I need to first declare a constructor for this class. To create a constructor, I use the class name, parenthesis, this dot name, this dot age, and this dot college. Now that I've created the constructor, I can create a method or a behavior for objects of this class. I want to create a behavior that says void study. What this does is it prints name studies at college. Now, if I want to create an object using this class, this blueprint, up here, I will create an object, student. I'll name it S1, and then I'll call the constructor. So student, I need to pass name, age, and a college. So Flutter, let's say 25, and college, let's say Harold. Then I can access methods inside this class, which is study. I can call s1.study, which should return Flutter studies at Harold. Works. But this is redundant. As you can see, name and age are already properties that exist in the class person. There's a simple solution to this, and it's called inheritance. You can use the keyword extends a class. So what this does is that now the class student inherits all the properties and variables of the class person. Student now automatically has access to name, age, and all of its behaviors. So in this case, greet. I can modify variables in the constructor of student class. So I do not need to explicitly mention name and age anymore. In the constructor class, I do not need to pass in the arguments for name and age, but I need to call super. So I need to call super and say name and age. The constructor requires now name and it requires an age. So what's happening on line 32? Student owns only college. So the college variable or the college property is only owned by student. Super name age calls the constructor of person. So when I say super name age, it calls this constructor. So it takes in the argument for name and age. The parent class initializes the parent variables. So since the class student extends person, person is the parent class, and the constructor in parent class initializes parent variables. The child student initializes child variables, which is college. The effect of that now is I can call s1.greet. As you can see, even though this behavior isn't defined inside the student itself, since it extends person, it derivates all the properties and variables of person inside it, so I can call methods that exist inside person.
That's all for this episode. We covered a lot of topics in this episode, so it's completely fine for you to get confused along the way. You can go back, look through the topics again, revise the topics again before continuing on to the next episode. The next episode is all about widgets in Dart. I look forward to seeing you there. Welcome to episode 3. If you followed our Dart lesson, you now have the tools to manage data. But how does that data become a visible app? The answer is widgets. In Flutter, the phrase is everything is a widget. A button is a widget. The text on the button is a widget. The spacing around the button is a widget. And even the entire screen is a widget. They are the basic building blocks you snap together to create your UI. Widgets are classes. This is the most important concept to carry over from our Dart lesson. Every widget is a Dart class. Just like we define the properties for our user class, the text class contains properties like font size and color. When you write text hello, you are using a constructor to create a text object, which is a widget ready to be placed on the screen. The widget tree. Because widgets are just nested classes, they form a structure called the widget tree. Look at this diagram. Every widget is a parent that contains one or more children. The scaffold widget is the parent that provides basic screen structure. It holds a center widget, which in turn holds a text widget that you might want centered on the screen. Stateful and stateless widgets. The next crucial distinction divides all widgets into two family classes: stateless widgets and stateful widgets. Stateless widgets are static or immutable widgets. Stateful widgets are dynamic or mutable. Let's see what that means. Stateless widgets can never be changed once they're built. So once a program runs, the stateless widget structure will never be changed throughout its life. Stateful widgets can be changed based on the user's input, and stateful widgets are the dynamic elements of your screen that change over the course of time. Stateless widgets are perfect for things like company logo, a copyright notice, or a fixed title. Stateful widgets can change on user input, like when you tap a button, or when data arrives from the internet. This changing is what we call a state. Let's look at stateless widgets first. Let's look at its simple structure. A stateless widget extends the base stateless widget class, and its only job is to provide one function, the build method. The build method is where the magic happens. It tells Flutter what to draw on the screen. Since the data given to it is a stateless widget which is fixed, the build method always returns the exact same UI. This makes them highly efficient because the UI does not have to change multiple times throughout the program. It is declared at the start of the program and remains the same throughout the program. Let's look at stateful widgets. Stateful widget is a more complex widget because it comes in a pair. The main stateful widget itself is static. It's just a shell widget. It delegates the responsibility for managing the mutable or changing data to a separate companion class called the state class. This state class holds changing variables, like our counter variables or changing weather conditions. Whenever the state changes, only the state class rebuilds its part of the UI. Remember this: the widget is the static container, and the state is the mutable data. That was all for this episode. It was a very short episode, but very crucial to move forward with Flutter app development. We've covered the fundamentals. Widgets are nested classes that form the widget tree. We use stateless widget for static UI and stateful widget for dynamic UI. Now that we know what widgets are, where do they live, next time we shall jump into Android Studio to explore default project structure and figure out where all these files go. See you in episode 4.
Welcome to episode 4. We've talked about Dart for logic and we've talked about widgets for visual structure. Now it's time to put our archaeologist hats and dig into the actual files that Flutter and Android Studio created for us. Understanding this project structure is essential because it tells you exactly where to put your code and assets. Although we've already looked at project creation with Android Studio, let's go over it once more. Open Android Studio. Make sure that in your settings you have the correct SDK components, SDK platforms, and SDK tools installed. Hit OK. Under plugins, make sure you have the correct plugins installed. Now we can create a new project. Click on the new Flutter project. Locate your Flutter SDK path. Click on Next. You can give this project a name. I'll be naming it just Flutter project. You can give it a description. I'm leaving it empty for now. And I will deselect Linux, Mac, Web, and Windows since we're creating applications only for Android or iOS. You can create a new project. Once you create a new project, the files right here in the root, like readme YAML and gitignore, are configuration files. You generally won't touch these. The project structure is clearly divided into different responsibilities. We need to focus on 3 folders and 1 file. First are the Android and iOS folders. These folders contain the native wrapper for your app. Think of them as shells that host your Flutter engine. Your Flutter code runs inside these native projects. If you need to add special permissions like access the phone's camera or access the phone's location, you will add it under these folders. Next, the important thing that we will be working on is the pubspec YAML file. First is the name and description. This split is self-explanatory. Next, we have the dependencies. This is the most important part. If you want to use an external code, say a package to connect to the internet, or a package for animations, you add it here under dependencies. When you save this file and hit on pub-get, Flutter automatically downloads the code and assets for you. Talking about assets, you can add local assets under this section. If you want to use images or custom fonts, you must download them to your local computer and add them or declare them here under the assets section so that Flutter knows when to find them. The core folder of our project is the lib folder. Currently, it hosts only the Dart file. Everything we build for this course, all our widgets, all our screens, all our Dart logic, will go inside this folder. When you create a new Flutter project, it contains a single main Dart file. Let's dissect the default counter app code inside the file. But before we do that, let's run it on our physical device. To do that, I will connect my physical Android device to my laptop via a USB cable. Remember, you must have developer options and USB debugging enabled on your phone to be able to do this. If you do not have that, you can create an Android virtual machine. To do that, please go ahead and refer to the first video that we made on Flutter app development. I've connected my device now, so under devices here, you can see my phone. You can hit this Run Main Dart button to upload the code to your Android phone. As you can see, my app has started. Now let's learn about one essential tool in development that you will need while using Flutter. It's called the Hot Reload and Hot Restart tool. Let's look at the Flutter's project structure at first. So this is the main Dart file that we have run on our device. It looks inside the main function. This is the function because it has small brackets and curly brackets followed by it. This is the function body. We have a keyword void here. That means this main function does not return anything. Inside the main function, we have a method called runApp. The method is calling a widget. Remember, this is a widget. All the things in Flutter that you see highlighted by blue are widgets. This is my app. This is our class. Widgets are classes. This is a stateless widget. So remember how we did extends and remember what stateless means. Stateless means that once built, it will never update again throughout the lifecycle of the program. Extends means we're creating a new class that has all the properties of its superclass or parent class. This is a constructor. The constructor is accessing a key from inside the parent class. This is constant because we do not want it to change. We create it once and we do not touch it. Inside our class, we have a build method. Now this override key, basically what it does is the stateless widget class also has a build function. But what we're telling Flutter is not to listen to the build function inside Stateless widget class, but listen to the build function that we have mentioned here. So this build function will effectively override the one that already exists inside its parent class. Inside the build function, we're returning a widget. The widget's name is MaterialApp. So this is another class. This is a widget. MaterialApp has some properties. So you can give it a title, you can give it a theme, and you can give it a color scheme. But the main thing that we need to look at is you can give it a home. Inside home, we pass in another widget. So you can see how the widget tree structure works in Flutter. This widget is called My Home Page, and I'm supplying it with a title. So if we see here, My Home Page is a stateful widget. So My Home Page can change states. So it's dynamic, it can change states throughout the program. This is the constructor for My Home Page. Look at this, it says required this title. But instantiating this class, we've passed in a title. Remember that stateful widgets come in two classes. This is its home class, and this is the class where we set all of our code. So all of our code is inside this class. Let's see what this class has. It's returning a scaffold. A scaffold is basically a structure that you build your page upon. Under scaffold, you have a property called app_bar. App_bar is this purple structure that you see over here. So the background color is the theme that we've mentioned here. So it is deep purple that we've mentioned here. There's a text called widget.title. So the title that we passed here is Flutter demo homepage. And we have a body. The body attribute has another widget inside it that is centering another widget, which is a column. So inside the column, we have a text widget that shows how many times we've pressed the button. It returns a counter, and it has a style attribute that gives it its theme, which is the text size. We have a floating action button. So this button over here, we have a floating action button widget that on pressed calls the increment counter. So this counter increases by 1 when we press this button. Let's try that out now. If I press this button, this counter is updating. Now what is Flutter hot restart and what is Flutter hot reload? If you want to change a UI component of the app without changing the state of the app, you perform a hot reload. If you want to change the state of the app entirely, you perform a hot restart. Suppose if I want to change this UI component from Flutter demo homepage to just Flutter homepage, I will delete Flutter homepage and I will save. Saving in Android Studio automatically performs a hot reload. So you can see it changed from Flutter demo homepage to Flutter homepage. But this counter that shows the number of times you press the button is still 6 because this is the current state of the app. The current state of the app includes all variables declared inside the app. So over here we have int counter variable. So counter variable is a state. To reset the state or to set this back to 0, you need to perform a hot restart. For example, if I change this to 10 and save it or perform a hot reload, nothing changes. But if I set the initial counter to 10 and perform a hot restart by pressing this button or by pressing Ctrl+Shift/, it will hot restart the application. And now I have 10 by default. If I set this back to 0, perform a hot reload, this 10 will not go away, but if I perform a hot restart, this 10 will reset back to 0. Great job! You now know the topography of a Flutter project. You can now manage basic files in a Flutter project. You know what the pubspec YAML file does and how to add assets and dependencies to it. You know what the lib folder is and that all your root files and Dart files lie in the lib folder. You can now perform a hot reload and you've learned how to do a hot restart. Next time, we finally delete all the default code in main.dart and start building our app's primary layout. We'll introduce 2 essential widgets for any screen, the scaffold and the app bar. See you in episode 5.
Welcome back. In episode 4, we learned the structure of a Flutter project. Today, we finally threw out all the messy boilerplate code that Flutter gave us and we built our app's basic screen structure from scratch. You are about to write your first foundational Flutter code.
Open your project's main Dart file. Select everything and delete it. Start and clean helps us understand the minimum required code to display anything on the screen. The first thing that you need to do in a Dart file is import the Material Dart package. The Material Dart package contains all of the theming tools necessary to build your app. So simply import Material Dart into your application. The next thing that we need to do is create a main function. Since all programs run from the main function, you need to define a main function. Inside the main function, we're going to run an app and we will return a constant widget called my app. A constant widget cannot change, so we're basically saying that we want to return a stateless widget. To create a stateless widget in Flutter, there's a shortcut in Android Studio. So start by typing stless and hit enter. Name this my app. It automatically creates the constructor and build method for you. So what we're doing here is we're creating a main function. The main function returns a constant myApp widget. MyApp widget is a stateless widget. That means once built, this will never change states. But what does MyApp contain? Right now, it just contains a placeholder. We will delete this placeholder and return a material app. We will return a material app. Now, what do we actually want to display inside the material app? Let's just say for now, under the home property in material app, we want to display a text. So to display a text, I need to create a text widget. In the text widget, I will pass in the text. So, hello, Flutter. Keep in mind, you cannot directly type hello, Flutter this way. You need to create a text widget this way. If we run this program now, you will just see the text in the corner with no structure. That's because we're missing the foundational layout widget called the Scaffold widget. Think of the Scaffold widget as the canvas or the sketchpad for one screen of your app. It provides the standard visual structure of any mobile app. Let's replace our simple text widget with a Scaffold widget. So to do that, instead of returning the text widget in the home property, we will return a scaffold. Inside the scaffold, it has a body property. The body property will return a text widget. So I'll write the same thing, hello, Flutter. And now remember, you can either save to perform a hot reload, or you can press this button to run a Flutter hot reload. Now, although hidden by my top activity bar, you can see that behind it, it says hello Flutter. The screen is now white. That's progress. The scaffold widget has many properties, but we'll focus on the 3 most common properties in this video: the app bar property, the body property, and the floating action button property. The app bar property is basically where we place the title bar at the top of the screen. To create an app bar, simply go ahead and let's remove the body property for now, create an app bar property where we return an app bar widget. So you can get familiar with this over time. As you can see, all we do is create properties, and under those properties, we pass widgets. So this is basically how you code applications in Flutter. You create properties and you pass widgets inside properties. In app bar, you have a property called title. You can pass a text widget inside the title property. In the text widget inside the title, we can put in a title. So for this purpose, let me give something like my first Flutter app. Now, if we conduct a hot reload on this, you can see an app bar is previewed with the text my first Flutter app. Now, it's not really clear where our app bar lies, so you can give it a color by passing in a color.
So to pass in a color, you do colors dot, and you can select a color. Let's give it indigo. Now, if I perform a hot reload by saving this file, the app bar is now clearly visible. The app bar widget itself takes properties. We set title property to another widget, the text widget. We use colors indigo property to quickly set a nice dark blue color, and we used hot reload to have that clean colored top bar. The text body property is where the primary content of your screen goes. It takes up all the remaining space below the app bar. Let me add a body property. To add a body property, you have to come outside the app bar. So our app bar is defined in this block here. So to add a body property, I'll give a comma and type in body. Remember, in Flutter, it is important that you add a comma after each property. Even if there is a closed parenthesis, you can still add a comma. This will not give an error. It's always a good practice to write commas at the end of most of your lines. Let's give it a body property. In body, I want a center widget. What a center widget does is it takes everything that you pass inside it and centers it wherever it lies. So since currently this center lies in the body property, and the body property is basically the entire space below the app bar, this will center it throughout the screen. It takes a property, child. Under child, you can pass in a text widget. In the text widget, you can pass in a text, so body content. You can style a text widget using the style property of the text widget. So style, pass in a text style widget, and you can define multiple things here. So you can define a font size, you can define different font families if you've imported them, and you can define colors for your font. So let me say colors dot red. If I perform a hot reload, you should be able to view body content centered on the body portion of your screen. I've placed the center widget in the body. This is our first major layout widget. It takes one child and centers it in the middle of the available area. Its child is a text widget, where I've also used a text style object to make the font larger. Again, I've used hot reload to perfectly center our text. Now, one last thing that I want to do before we end this video is add a floating action button. A floating action button, or FAB, is a circular button typically found in the bottom right used for primary action. So previously we had a floating action button that performed a counter action. We can create a floating action button by simply defining the property floating action button inside Scaffold. So inside Scaffold, this is our home, that is our app bar, so you can add floating action button. Inside floating action button, you need to pass a widget. The widget's name is also called floating action button. Notice the camel casing and the capital casing here. The floating action button has a property called onPressed. So that basically means it's basically trying to ask you what it should change when you press the button. I want to print something, so I will just print button has been pressed. Then in its child property, I can add an icon using the icon widget icons.add. Icons.add is an icon that we pull from Material Dart. Icon is a widget, and we're printing a button that has been pressed when we click on the button. If we perform a hot reload, as you can see, a button has been added on the bottom right part of our screen. Now let's direct our attention to the console here. When I click on the button on my Android device, you can see a button has been pressed is outputted into the console. No matter how many times I press this button, it keeps on giving me a button has been pressed. So what we did here is created a floating action button. It requires an onPress function even if it's currently empty. For the visual part, we give it a child, which is an icon widget. Icons.add is just one of the thousands of built-in icons we can access. Again, I perform a hot reload to have a complete structural screen.
You have just built the fundamental structure for every screen in your Flutter app. The text Material app defines the look and feel. The text Scaffold defines the screen layout using app bar and body properties. Next time, we go back to the concept of stateless widgets and the build method. We'll clean our main.dot file and learn how to use hot reload effectively to increase your productivity. See you in episode 6. Welcome to episode 6. Our app structure is solid, but visually it still looks like every other default Flutter app. Today is all about branding. We'll learn how to move beyond basic colors and use the powerful theme data object to set custom colors, topography, and even import unique custom fonts, giving our app a professional, unified look. Let's start our main.dot file from scratch. We need to import our material start. For importing our material start, we need our main function. Inside our main function, we need to run our app, and inside run app, we need to pass a constant called myApp. MyApp is a stateless widget, so we need to create a stateless widget called myApp. And myApp, instead of returning a placeholder, as we already know, it returns a material app. The Material app has a few properties that we've already explored. Currently, Material app is just generating a default theme. We're going to explicitly set it by using the theme property. So inside theme, we will pass a widget called theme data. This handles all of our theme related items in Flutter for us. We also need a home. Under home, we can pass a constant widget called main screen. Main screen, for this purpose, let's make it a stateless widget. So main screen is our widget, and main screen, instead of returning a placeholder, returns a scaffold. We can build our app on the scaffold. For now, let's give our scaffold a body. Let's center a text, and the text may be hello Flutter. So right now, if we run our application, for the purpose of this video, I'll be running my application within my desktop itself, but it's exactly the same if you run it on your Android device. To see how to run it on your Android device, please refer to the earlier videos in this series. I will perform a Flutter hot reload, and our application looks something like this. The theme and the colors aren't that pretty. You can change the theme of the app inside this theme data widget of the theme property in Material app. The theme data constructor takes all the properties we need to customize the look of the app from text styles to primary colors. For now, let's just set a primary background color. So for that, it has a property called scaffold background color. I want it to be a hex color. Now I'll show you how to implement a hex color into Flutter. So what you want to do is color, and inside color you pass 0xFF and then your hex code. So the hex code that I'll be using for this demo is E0F7FA. You can use any hex code that you'd like, and make sure to remove this space here. We use color class constructor. Notice 0xFF prefix. That's required for Flutter to interpret the standard hex code. So without 0xFF, Flutter cannot recognize that E0F7FA is a hex code. Perform a Flutter hot reload, and you can see that the background color slightly changed from a white shift to a light teal background. Next, let's edit the styling property. Let's control the fonts globally. Text theme property lets us define styles for every type of text widget in the app: headings, body text, captions, and more. So inside the theme data, we can add a property called text theme. Text theme takes a constant widget because we want our theme to be constant throughout the program, called text theme. The text theme widget in turn takes a few properties. It takes a title large. So if you want a large title, it will pull the properties for the title from this property of the text theme widget. Inside this, we pass a text style widget. Inside the text style widget, we can define properties. So font size, let's say 22. Font weight could be font weight dot bold, and color could be colors dot green. If we perform a Flutter hot reload, we won't see any changes because right now none of our text in our application uses the title large style by default. What does use the title large style by default is our app bar title. Now, if you remember how to implement the app bar, it's right under Scaffold. So app bar property, we pass in an app bar widget under which we can pass a title, and this title has the title large style. In title, we can pass center widget, and inside the center widget, we can pass a text widget that says this is app bar title. Oops, this needs to be child. And now if we perform a Flutter hot reload, the app bar title widget has automatically taken the properties of the title large property that we defined in text style of theme data. So if I change this font here, by default, your app bar title moves. Your app bar title's font changes. Now the advanced part, using a custom font that isn't included by default. Fonts are external files, so we must treat them as assets and tell Flutter where to find them. First of all, we actually need the font files. So the place where the font files go is you can create an assets fonts folder in our project root and drop our font files. Inside our project root, you can create a directory. You can name the directory assets. And under assets, you can create a subdirectory called fonts. Now inside fonts is where all your font assets will go. To search for a font asset, simply go to your browser and search for the font that you'd like to get. So you can search for a Roboto font. Click on the first link that fonts.google.com gives you. Click on Get Font, and you can download this font. For this demonstration, I downloaded the Roboto font zip file, extracted it, and pulled in one random TTF file from inside the Roboto static fonts. So the font that I want to implement throughout my program is called Roboto Regular. So the first thing you do is go into your pubspec YAML file. Find the section that has fonts listed. You want to uncomment this section by simply pressing Ctrl/. If there's an indentation error, make sure you properly indent your fonts. So inside family, you want to write Roboto. And under assets, you want your folder name, which is assets/font/roboto-regular.ttf. We don't have any other asset styles or any other families, so we can delete all of this. Now, please save your pubspec YAML file and click on pub-get. So after you click on pub-get, it will automatically update all of your dependencies. If you do not click pub-get, Flutter will not recognize your text file. Flutter will not recognize your TTF file as it does not get imported until you press the pub-get button. Now that your font has been imported, you can finally use it inside your widgets. We can apply our font globally via theme data. Inside your theme data, go under your text theme widget, put a comma, and write theme font family. You can choose your font family using this property. So you want to type in Roboto. So this name has to exactly match the family that you've provided here. If this matches, then it will automatically pull the assets under Roboto family and use it in your program. The font family property inside theme data globally overrides the default font. The string name here must exactly match the family name that you defined in your pubspec YAML file. After this, you need to perform a hot restart since we're resetting the state of the entire application. After you perform a hot restart, you should see that the entire app is now using your custom brand font. Today you learned how to take full control of your app's presentation by using theme data object inside the Material app to set colors and typography globally. You also mastered the critical step of declaring and implementing custom assets like fonts using the PubSpec YAML. Next time, we finally introduce dynamism. We will build our first stateful widget to create interactive UI focusing on state class and setState method. This is where the real app logic begins. See you in episode 7.
Hello and welcome back to the course. In our previous episode, we focused heavily on aesthetics. We styled our app using themes, custom fonts, and colors. We made the UI look good, but if you interacted with that app, you likely noticed a significant limitation. It was frozen. Nothing moved, nothing updated, nothing reacted. That is because, until now, we have exclusively used stateless widgets. In the rules of Flutter, a stateless widget is immutable. Think of it like a printed photograph or a painting on a wall. Once you paint it, you cannot change the color of a specific tree without painting the entire canvas all over again. It receives data once, renders it, and stays that way forever. But modern applications need to be alive. We need to track user inputs, timer ticks, network responses, and button presses, and so forth. To do this, we need to introduce a new concept called state. Put simply, state is just the data your application needs to display at any given moment. Data that can change during the lifetime of a widget. Today, we leave the static world behind. We're going to learn about stateful widgets and the most critical method in the entire framework, the setState method. Let's jump into code. I've cleared our previous project to start fresh. We are going to build a classic counter app, the hello world of dynamic interfaces. First, I want to show you the limitation of what we already know. We've already learned how to make a standard stateless widget. So let's start by doing that first. Firstly, we need to import our libraries, which is Material.Dart, which contains all of our styling options by default. Then we need to start our app from void main. Inside void main, we need to return a Material app. Material app requires a home. Inside home, we can reference a widget. So we're creating a custom widget. Let's call it the counter screen widget. So this is currently an error because counter screen is not defined yet. So let's start by what we already know. We know how to make a stateless widget. So start by typing stateless and press enter. Name this widget counter screen. You've now created a counter screen widget. Inside the void main function, you're running an app, you're returning a Material app, and in the home of the Material app, you're returning counter screen widget. Your counter screen widget is a stateless widget. What does this widget return currently? Well, nothing. It returns a placeholder. What we do is we return a scaffold. This should be standard practice by now. You should have all of this memorized. We can start by creating an app bar. So to create an app bar, you simply give the app bar property. Inside the app bar property, you create an app bar widget. And inside the widget, you can have a few things. So the first thing we can have is the title. So under title, I want a text widget, obviously. And in the text widget, I want it to say state demo, for example. What are the other properties of a scaffold? A scaffold has a body. Inside the body, I want to return a center widget. The center widget could have a child. A center widget always needs a child. And under child, I want a text that simply says let's say 0 for now. I want to edit the text style of this text so that it's a bit more visible towards the center of the screen. So I can do that by using the style attribute, and under style, I'll pass a text style widget. And inside the text style widget, I can set a font size. I can set a font size, suppose 50. If I run this app now, we will get a very simple application. This is our app bar. It is not centered on anything. That's why it is aligned to the left. It says state demo, exactly as we've said here. In the center, we have a text that simply just says 0 with a slightly larger font size than the app bar. Now, logically, if we want this number to change, we need a variable to store it, right? So let's start by doing that. So you want to add a variable. Let's try adding a variable directly inside our stateless widget. Int counter equals to 0. Counter equals to 0. I've added an integer called counter, but look at this. If you have your linting rules on, your IDE might already be complaining. It's telling you that fields in a stateless widget should be final. So if you hover over this, it will tell you that try making all of the fields final or removing the keyword const from constructor. Why? Because technically a stateless widget is meant to be immutable. It shouldn't hold any data that changes throughout the execution of the program. To fix this properly, we need to upgrade this class. This is where stateful widgets come in. We need a widget that is capable of maintaining state across multiple frames. We need a mutable widget. Watch this code closely. I'm going to use an IDE shortcut to convert this immediately. You could go in here and delete all of this and completely recreate it using a Stateful widget, but that would be a long day. So let's immediately convert this using an IDE shortcut. Click on your class and this icon will appear. When you click on this icon, it simply says convert to stateful widget. If you click on this, your IDE will automatically convert your stateless widget into a stateful widget. This is the most confusing part for beginners. So let me break down what just happened. A stateful widget is actually two classes linked together. The top class, the counter screen class, is still immutable. It's just the configuration, the public face of the widget. So if I still try to create a variable inside here, int counter equals to 0, this will still be a mistake because technically this class is still immutable. But the beauty of stateful widgets is its second class. The second class starting with this underscore counter screen state is where the magic happens. This class is what we call a persistent class. While the UI might get redrawn, this state object stays alive in memory. This is where we store our mutable data. Now, let's try to modify our data. I'm going to add a floating action button to our scaffold so we have something to click. So, a scaffold has another property called floating action button. When you create a floating action button, you pass in a floating action button widget. Inside the widget, you can have a few properties. So, the first property that is recommended is having a child. I simply wanted to have an icons dot add, let's say. Then a must for a floating action button is that it needs an on press property. So what is actually supposed to happen when you click the floating action button? Oops, seems like I've written location here. Let me just remove that and everything should be fine. Okay, on pressed, what we want to do is if you press the floating action button, which is a plus icon on the bottom of your screen, I want to increase this counter by 1. So I can increase it by either doing counter equals to counter plus 1, or the shortcut method of doing this, which is simply counter plus plus, which auto increments it by 1. For the current purpose, let's just print this out into our console. So print the value of counter into our console every time we press this button. If we run this application now, pay close attention to the console as I press this button. As soon as I press it, the value of counter is outputted into our console. So every single time that I press it, our counter is increasing by 1 and it is being printed into our console. But that is not the point of this application. We want this text in the middle of the screen to increase every time we press the button. Let's go back to our code. Right now under text, we're hard coding it to have a string that is 0. So let's remove that and let's pass in the variable counter. If we run this application now, do you think that this text will change if I press the counter button? No, it does not. Even though in our terminal we can clearly see that the value of counter is increasing, and in our code we've clearly given counter into the text widget, it still does not change. Why is that? The data in the memory is updating. So why is the screen lying to us? This happens because Flutter is highly optimized. It does not constantly check every single variable to see if it has changed. If it did that, your application would be extremely slow. Flutter assumes that if you didn't tell it to redraw the widget, so if you didn't tell it to rebuild or redraw something, the screen should stay exactly the same. We updated the variable, but we didn't trigger a rebuild or a redraw. To bridge this gap between our data and our visual interface, we need to use the setState method. The most important method in stateful widgets is the setState method. Technically, the value of this text is changing. The value of this text is currently 5, but it has not been updated into our screen because we haven't triggered a rebuild. So the way you trigger a rebuild is, under your on pressed, you need to wrap your counter logic. As you can see, the ID is automatically recommending it to me, but remove your counter incrementing logic. I'm wrapping my counter plus plus logic inside the setState closure. When we call this, we are effectively sending a message to the Flutter framework saying, hey, I just changed some data inside this state object. Please mark this widget as dirty and run the build method again. So what is a dirty widget? A dirty widget is when the UI components are not up to date with its variable components. So technically, the value of counter was still changing, but the UI was not reflective of that. So that makes the widget dirty. What setState does is it marks the widget as dirty and runs the build method again. So it runs the build method again. When it reruns the build method, it updates the counter with the correct value. So if you run this now, you should see that the text in the middle of your screen should immediately update as soon as you press the plus icon. And it does. Immediate feedback. Here's the technical sequence of events happening in milliseconds. You tap the button. Firstly, the variable increments. Then the setState triggers. Flutter calls the build method again. The text widget is recreated, this time using the new value of counter. This cycle, event, state change, rebuild, is the fundamental heartbeat of almost every interactive app you will ever build. Let us summarize what we learned today. Stateless widgets are for static, non-changing content. Stateful widgets are for dynamic content that reacts to user input or data changes. State objects persist in memory to hold your variables, and the most important thing, setState is the trigger that forces Flutter to redraw the UI and reflect your changes. Now that we've made our app interactive, we need to make it beautiful and content-rich. In the next episode, we are going to dive into multimedia. I'm going to show you how to handle images, how to load them from your project assets, and how to fetch them from the internet using URLs. This is where your app really starts to come to life. Practice this counter logic, play around with it, and I will see you in the next video. Back. In our last episode, we breathed life into our app using state, making it reactive to user input. But currently, our apps are still just text and basic shapes. To build a modern, engaging experience, we need visuals. We need images. In Flutter, handling images generally falls into two categories, and it's crucial to understand the difference technically. First, we have network images. These are live on a remote server. Your app needs internet connection to fetch them. It stores it temporarily in a cache and displays it. They are dynamic, but they depend on internet connectivity. Secondly, we have asset images. They are images bundled directly into the application binary when we compile it. They increase the app size slightly, but they load instantly and are available offline. Think of things like logos, icons, or introductory graphics. While network images are easy, asset images require us to touch a file that intimidates many beginners, the pubspec YAML file. We spoke lightly about this in our previous episodes. Today, we're going to master both types and demystify that configuration file. Let's start in the IDE with the easiest method, fetching an image from the internet. I have a basic scaffold set up here from the previous episode. Now, I'll edit this to remove a few things. For example, we don't need this floating action button. And instead of a text widget being centered, I want something called image.network. Inside image.network, you need to pass a source. Your source will usually be a URL of an image that's hosted somewhere online. So if you Google something and you can right click on it, you can click open in a new tab and you can copy the URL to get that image address. So I've simply Googled the logo for Flutter and copied its image address and I'll paste it here. So it looks something like this. And now when we run the app, you can see that the Flutter image that I copied from the internet shows inside our app. Now, this image will always be centered no matter the orientation of the app, but you can see there's a slight border. So this image did not come with just the logo, but it came with a border. Now, why is that? That is because this image's URL is a JPEG. So JPEG images will include this background. So make sure when you're copying image assets from the internet that you have a PNG file for logos. Because if you have a JPG file or a JPG URL, then you'll get this background. I don't really mind this. Another thing that you can do is resize this. So let's say I want this to be slightly bigger. Then what I can do is I can go inside the image.network. I can add a comma and I can add a property. So I can add a property of width, maybe let's say 100. So if I perform a hot reload and go back to my application, the image has been resized. So you can customize the size and dimensions of your image using this. So since I'm assuming that our logo is a square image, then changing the width automatically scales the height. Or you could give width and height separately. So 500 would make it slightly bigger, so that looks much better. So let me explain what image.network is actually doing here. We're using image.network and all it requires is a string URL. I'm using just an example image to create a random placeholder. And when I run or reload the app, the image appears after a brief second. You'll notice that there's a small delay. So what is actually happening during that delay? Flutter makes an asynchronous HTTP request to that URL. So if you want to learn more about asynchronous and synchronous coding, you can look at more videos on the channel. It downloads the image data stream and it decodes that stream into image pixels. And then it proceeds to render the frame and it even handles basic caching for you automatically. But what if the user is on an airplane? The image won't be able to load. For vital UI elements, we need a robust offline solution. That's where image.asset comes in. To use images stored on the device, we actually need to tell Flutter where they are first. So this brings us back to our pubspec YAML file, which is also known as the project manifest file. Look at your project file structure. Way down at the bottom, you'll see the pubspec YAML file. I already have it open over here. This is the file that holds your heart of your project, configuration. Defines your app's name, description, SDK version, any third-party packages that you use, your assets, and so on. A critical warning before we touch anything. This file is written in YAML, which stands for yet another markup language, and it is extremely sensitive to your indentation. So if you add the wrong indentation, it will immediately throw an error. It does not use tabs for indentation, it actually uses spaces. So each indentation is 2 spaces, and if your indentation is off by a single space, your build will break. So follow along very carefully. Step 1, is organizing our files. So before we even enter the pubspec YAML file, we need to create a directory in our project to hold our images. Now, previously we made a directory called assets, and under it we made fonts. So if I want images, I can create a new directory and maybe call it images. Currently, I have nothing inside images, but let me just quickly move something into this folder. Conventionally, we create a folder named assets as the project root and often subfolders like images or fonts. Now, I've dragged a simple PNG logo into that new folder. Okay, the file is physically here, but Flutter does not know it exists yet. We must register it in the pubspec YAML file. Scroll down about halfway, you're looking for a commented out labeled section called Flutter. Over here, we've already uncommented it in our previous episode, so you'll have something that looks like this. These specific lines are the lines that we need to uncomment. So simply press Ctrl/ to uncomment these lines and fix the indentation on those. After we've done that, notice that this Flutter is the parent, assets is indented 2 spaces, and the hyphens indicate a list item that is also indented another 2 spaces. The path inside must be exact relative to the project root. So our project root is my project, so the path for my image folder would be simply assets/images and logo.png. You can also register just the directory like assets/images/ and everything that's inside that directory will be directly loaded inside your Flutter app. But since right now we just need the logo PNG, it's much more efficient to do this way. When you save this file, your IDE should automatically run a command called pubget. Alternatively, you can click on this button that says pubget. After your process finishes with exit code 0, you're good. If you get an error, just check your spaces, check your indentations. Now, for the final step, to display this image. How do we actually display this image? It's pretty simple. We change our constructor from image.network to image.assets. Once we change it to image.asset, you can remove this URL and instead give the exact path of the image that you want to load. So it is asset/images/logo.png. You can also add an optional controlling size like we did before, so let's do that too. And for this example, let me say width 200. If we run this program, that's my bad. It's called assets. Seems like I made a typo. Just double check your path if you're getting an error like that. So we ran this program and there it is. Our local asset loading instantly and ready offline. So once you compile your project, even offline, this asset is going to load. As I said before, you only want assets that you absolutely need to run even when offline to be able to register them without an internet connection. Most of your assets, however, will be hosted somewhere. It'll be online so that your Flutter app itself isn't all that heavy. There we go. To recap today's episode, we learned about network images, asset images, your directory structure, and your pubspec YAML. So making dynamic web-based images, using bundled offline images for your logos, creating assets folders to divide your images and fonts into different folders, and updating your project manifest files. Now that we have text, we have state, and we have images, everything is stuck in the center of the screen. We have no control over layout yet. So in the next episode, we're finally going to take control of the canvas. We will dive deep into layout widgets, specifically the container, padding, and margin. These are tools that you need to position elements exactly where you want them. See you there. Welcome back. At this point, we've built an app that can count numbers, state, and display pictures, images. But visually, it's a mess. Elements are smashed against edges on the screen or stuck awkwardly in the center. It looks like a prototype, not a product. To fix this, we need to master the most versatile widget in the entire Flutter catalog, the container. If you are coming from web development, you can think of container as your div, but on steroids. The container is your go-to tool for three things: painting, adding background colors, borders, shadows; positioning, moving elements around with margins; and sizing, controlling width, height, and internal spacing via padding. So to do this, we look at box model. In the innermost layer of the box model, you have your content. Outside your content, the first layer that you have is your padding. So if you increase your padding, your content gets smushed towards the center. If you decrease your padding, your content has more space to breathe or scales up. Outside padding, you have your border. So border is the next visible element on your screen aside from content. Padding is usually a transparent element that is usually just used to manage spacing. And to top it all off, you have your margin. So margin is the outermost layer of the box model that separates one box from another box. So let's say if I had two contents side to side, what would separate them from each other? Obviously, you'd have the border, but if you stuck the border to each other, they'd practically be indifferentiable. So you have margin. Margin is the space between borders. So in the box model, generally, your margin and your padding are invisible elements, and your border and your content are the visible elements. The biggest point of confusion for beginners is the difference between padding and margin. We're going to visualize this in code today so you never mix them up again. Let's head into the IDE. I have our image from the last episode. It's just floating in the center. Let's wrap this image in a container to see what we can control. Let's have a look at our application first. So this is the image that I have in the center. Now I want to wrap this in a container to see what I can control. So first of all, instead of directly passing image asset as a child, what I want to do is I want to pass a container as a child. So inside container, I can have another child, and in this child, I want to pass in the image. So if you remember, it's image asset, then you give your source, which is assets, images, logo.png. So currently, if you run this code, nothing happens. Visually, a default container is invisible. It simply hugs its child tightly. To see the container, we need to give it paint. This is actually my number one tip for debugging layout issues. If you don't know where a widget is, give it a bright color. So for this example, let's give our container a color. Let's give it a bright color like red. So if you remember how to give your color, you do not simply type red, you have to type colors.red. Don't forget the comma. If you perform a hot reload and go back to your application, now you can see this red box. It's the exact same size as our image, and the container effectively shrinks to fit its content. Now we can dictate the size of a container. If I want to change the size of the container that is hugging our image, I simply pass in width. Oh, don't forget the comma. If I perform a hot reload now and go back to my application, you can see that I've got hard-coded the width and height to 300. The red box, which is our container, is smaller than our Flutter logo. So the container has taken control of the layout constraint. It made the logo, which is inside the container, also shrink alongside the dimensions of the container. Now for the main event, spacing. We can use edge insets to define a class space. First, padding. Padding is the space inside a container. It pushes the child away from the walls of the container. So to add padding, you simply write in the property padding and give it a value. So before we give it a value, you cannot directly apply a value to padding. You have to define what kind of padding it is. And to do this, we use edge insets. So if you type in edge insets all, then it will give a padding everywhere. There are multiple properties of edge insets. So you can do edge insets only to give a padding only to top, left, bottom, or right. Or you can use from LTRB to give left, top, right, and bottom individually. Let's start with all. So it expects a value. Let's give it a value of 20. So if I save this now and come back to my logo, you might not see much of a difference. Let me put this on top so that you can visually see the difference. If I change my padding to 0, so basically no padding, opposed to if I change my padding to something like 50. So you can see the logo is shrinking or the logo is expanding based on the padding that I give, because padding is this space between the logo and the container. So the more padding you have, the more space that you'll have before the border kicks in. Now, edge_insets.all is one example. You can have edge_insets.only. So if I want only padding on the top, I can give edge_insets_only with a value of 50, let's say. I need to define which. So you need to define either you're giving top, left, right, or bottom. So if I want to give a padding of 50 to only the top side of this container, I'll type edge_insets_only top 50, perform a hot reload, and you'll see that padding has only been applied to the top. This might be useful depending on your use case scenario, but that's how padding works. The background stays the same size, but the image actually squeezes inwards by 20 pixels, or in this case, 50 pixels. So that is what padding is. The object or any element that you place inside the container that contains the padding will be shrinked, whereas the container remains the same. Now let's talk about margins. So margin is the space outside the container. It pushes the container away from its neighbors. So the margin is this space, all of this space outside the container. So it's hard to visualize margin when your object is centered because it's pretty much far away from any other element by default. So handy thing in Android Studio is you can select a widget. And if you click on this button, you can delete that widget without having to deal with any broken errors or any broken closing statements or any commas or such. You can simply reverse it by Control Z, but you can click on a widget, click on this toolbar, and simply click Remove Widget. So if I hot reload this, then since this container is no longer centered to the screen, it will be by default aligned to the top left of the screen. Why did I do this? This is to better visualize what margins are. Since we changed the padding, the container itself never moves. The object or the elements inside the container moves. But what if I want this container to be away from the elements around it? So I want a certain gap between my app bar and my container. My app bar currently doesn't have a color, so let's give my app bar a color. It's background color. Obviously, you'll have much prettier colors in your actual designs, but this is just for demonstration. If I perform a hot reload, you can see that my container is tightly stuck to my app bar. If I want a gap here, what I will do is either I can give a margin to my app bar or I can give a margin to my container. I'll show it to you by giving a margin to my container. For now, I'll remove this padding and perform a hot reload, which resizes my logo to its original size. Let's remove this width constraint too. So my container is now hugging my actual original image and not resizing it at all. If I want a space on top, what I can do is give a margin property and inside edge.edgeinsets dot the same as padding. So only, all, from, or 0. If I want to give padding just to the top, then I can do only top and give a value for margin. This will move my container 50 pixels away from anything around it on the top. Notice how the box itself moved. It pushed away everything from around it. Padding is internal cushion and margin is like personal space. I used top 50 here, but generally you don't want a specific spacing only for a specific area. Either you want something that's like symmetric. So if you add symmetric, it will add padding to top and the bottom itself, or left and right itself. So for that, you either give it a horizontal symmetric or a vertical symmetric, or maybe both. So in this case, not only does it push it away from the top, but from the bottom too, from the left too, from the right too. If I were to place another element, it would appear exactly the same distance from the edge of the application as from the right edge of this container. Finally, we want to make this look nice. maybe some rounded corners, a shadow. To do this, we use the decoration property. Watch closely. I want to add a border radius to this box, so I add something called a box decoration to my container. I have to add a decoration property, and inside it, I'll pass a box decoration widget. In my box decoration widget, I can have a property called border radius, and inside border radius dot, you can have many types of radii, but I'll use a circular border radius and give it a value of 20. What happens if I hot reload this and we crashed? Let's read our crash message. Color equals to null, decoration equals to null. Cannot provide both a color and a decoration. So the error is pretty self-explanatory. The rule is if you provide a decoration, the color must be inside that decoration. You cannot have both a standalone color and a decoration in the same container. So if we simply move this color into our box decoration, the error should be fixed. And there we go. We have a nice looking border around our box. You can simply go through the Flutter documentation for more properties of the box decoration widget. I'll use some here now. You can have a border itself with border.all, so that you have border on the top, left, right, and bottom. Inside border all, obviously you can have a color and you have a border width. If I perform a hot reload, then I'll have a width of 2 pixels all around in the color black. You can also have something called a box shadow. So a box shadow, make sure that you're closing your brackets properly so that you do not create properties inside of other properties. This might be tricky at first, but you'll get the hang of it. Box shadow can have a few things. So a box shadow needs to be a list. Inside the list, you'll have a widget box shadow, and inside the widget, you have a few properties. So you can have a color of the shadow, gray. You can have a blur effect that they normally have on shadows, or you can have something called spread radius. You'll see this in effect once I hot reload this. You can have a blur radius and an offset. If I perform a hot reload, you can see that the spread radius is how far it spreads from my original box. The blur radius is how much to blur it. So if I set my blur radius to 0, this won't be blurred at all. It'll simply just appear gray. The more you increase this, the more blur it seems. The offset is how much it moves from the center. So on my x-axis, I'm offsetting it by none, and on my y-axis, I'm offsetting it by 3. Now this may not seem very visible, but if I change it to a ridiculous value like 50, you can see that on the x-axis, it did not change at all. So x is your horizontal axis, and on the y-axis, it moved down 50. If I change it on x-axis too, you can see that it moves on the right. So you'll notice that in applications, your y-axis increases when you go down, and your x-axis increases when you go right. So your exact 0, 0 or point of origin is on the top left portion of your screen. This is your origin. Since there is no point above this, when you go down, you increase in y. When you go right, you increase in x. Now, in this case, as I said before, I moved the color inside, so there's no error. I've added a border radius for soft corners, a black border line, and a box shadow to give it some more depth. Now, this is a UI element. It has shape, it has depth, it has proper spacing, and you can customize this however you'd like. To recap, the container is the workhorse of Flutter layouts. Let's review the key takeaways. Container is used for sizing, painting, and positioning of elements throughout your screen. Padding. It basically adds space inside the box, which in turn shrinks your content, moves it away from your border. Margin. It adds space outside the box, it physically moves the container itself, and it adds space in between different containers. Box decoration. You use it for styling. You can have corners, shadow borders, you can have colors, and the most important thing, remember that if you're using a decoration, then all the decorative properties such as color will have to be inside box decoration. So if it's outside your box decoration, your app will crash. We've mastered the single box, but apps are usually made of many boxes. We need to stack them vertically like a list or arrange them horizontally like buttons. In the next episode, we are going to learn the two most important layout widgets in existence, the rows and the columns. This is how we actually build full screen layouts. See you there. Welcome back. In the last episode, we mastered the individual box, the container. But apps aren't just one box floating in space. Apps are collections of elements arranged together. Sometimes they're stacked vertically, sometimes they're lined up horizontally. Think of the last app you used. Maybe it had rows for sharing, or a star rating system, or a navigation bar at the bottom. These are all horizontal layouts. To build this, Flutter gives us the row widget. It sounds simple, it puts things in a line, but to master it, you need to understand two critical concepts, the main axis and cross axis. So for a row, the main axis is the horizontal line from left to right, because a row is a horizontal component. For a row, the cross axis is your vertical line from top to bottom. Understanding how to control alignment along these two axes is the difference between a messy app and a professional app. Let's dive into the code. Let's start fresh here. Let's see where we left off last time. So we did a couple of things last time. We had a container, we added some decoration properties, and we had some padding, some margin, some borders, and so forth. So for this time, I'm going to start fresh. I'll remove the app bar and I'll remove this container so that we just have an empty app. So let me go here and remove the app bar and remove the child and the container. So currently, if I run this application, it should show up with nothing. All right, there we go. Now let's build upon this. Firstly, we need a body. So in our body property, let's have our row widget that we're gonna take a look at first. Now, usually with widgets, we had something called child property, where you passed in another widget. So for example, in a center widget, you'd have a child property, and in your child property, we previously passed in text widgets to center a text, or you can pass in image.asset or image.network to center images. But row and column are different. Because think about it. Does row only have a single child? No, it doesn't. Row has multiple elements inside it stacked horizontally, so from left to right. So row has a property called children inside instead of child. So children is actually a list of other widgets that you can have, and the row widget automatically handles those widgets alignment for you. So inside our children, we can have multiple different widgets. So we have multiple different containers. You could have one container widget, you could have another container widget, and you can have another container widget. So for this example, let me start off with 3 container widgets. Simply to start, let me just give this container widget a width of 50, a height of 50, and let's give it a color. Let's give it a color, colors.red. For our second container, let me do the same. And for our third container, let me do the same. If I hot reload this by saving it and go back to my application, you'll see something that looks like this. Now, since all of these are the same color, they look bunched up together, so you can't actually differentiate them. So let me fix that by changing their colors. So red, blue, green. Now, if I save this, you can see that there's actually 3 boxes attached to the top left corner of my screen. As I mentioned in my previous video, your origin in an application for Flutter is on the top left. So the further right you go, you increase in the y-axis. More down you go, you increase in the y-axis. Since I haven't defined a position for it yet, just a width and height, it's automatically stuck to the top left portion of the screen. My red container is constructed first, then my blue container is constructed, then my green container is constructed. Since they're all children of a row widget, the row widget automatically places them in a row. Now, unlike container or center, which takes a single child, row widget takes a list of children. This is the default behavior. As we talked about containers in the last episode, a row will also always try to be as small as possible and hug its children. So the row is actually as big as its children elements are. If I passed a image.asset instead of a container directly, you'd have a image.asset here. So you'd have an image and that row would still be hugging the image tightly. Now let's spread them out. We need to use a property called main axis alignment. Since we're in a row, as I said before, the main axis is your horizontal axis because the purpose of a row is to list items or arrange items horizontally. Let me add a property inside row. It is always a good practice to have children as your last property. So if you're going to add any more properties, you usually add it above children. So a property I want to add is main axis alignment. It takes another widget, main axis alignment dot, and you have multiple properties. So let's try dot center. If I perform a hot reload, you can see that all my items that are inside the row are centered. So what that does is it centers the row on the screen. It takes the width of the screen and then centers the row perfectly. So if I add any more elements, it'll automatically go ahead and center that for me. If I add another container here and hot reload, change this color to, and it'll automatically center all of this for me. So this is all perfectly in the center. Let me remove that widget for now, but we also have other options. Let's try space between. So space between places the first child at the start, the last child at the end, and evenly spaces everything in between. So this is great, especially if you're having toolbars. Usually what you'll have is these are just containers. Inside the containers, you'll have different icons or you'll have different logos. And the icons and logos can be smaller than the containers. The container is just the space that occupies that entire area. You cannot have another container inside a container, so it'll take up that area for it. For example, I'd have a search icon inside this red container, and I could place this red container anywhere on the screen and make the background flush with my app background and just have the toolbar icon show. So just have the search icon show. Let's try something called space between. So under here, I'll add another property called space evenly and set it to. So I'll change my main axis alignment dot center to dot space between. If I perform a hot reload, you can see that it places the first at the first and the last at the last. So if I actually had another element here, so if I had another element, same as before, yellow, what it would do is it places red at the first, yellow at the end, and everything else, it aligns it with equal spacing in the middle. Next, space around. So space around actually puts equal space around each item. Notice the gap on the far left and the gap on the far right will be half the size of the gap between the items. So let's see that practically. Space around, space around. Let's hot reload. There you go. So each item has equal gap between them, but the starting item and the ending item has only half the gap from the edge of the screen. The next option we have is space evenly. This makes every single gap perfectly even. Space evenly. So this makes all the gaps perfectly even. Space around and space evenly can be used interchangeably, and you can do this in this way, but you can also add margins to each container, or you can add padding to each container and align it that way. So instead of main axis alignment, what we learned in the previous episode is margin and padding. So this container itself can have a margin property, edge insets, let's do symmetric, and let's do horizontal. So if I set this to 50, this will have a 50 gap to the left, a 50 gap to the right. So I can add space between just two different items or just one different item. I can customize the space as I want. But if you generally want to customize all if you generally want to add even space to all the items equally between each other, you'd use the main axis alignment. But what if you want to change this vertically? So if I want these elements to appear on the middle of the screen or on the bottom of the screen. This is cross-axis. To demonstrate this, I need to make one of our boxes taller than other boxes. So let me change our green box. Let me set its height to be 100. By default, our cross-axis alignment is set to center to the relative of the tallest item. So since the green box is my tallest item, it sets everything relative to the center of my green box. But I can change that property using cross-axis alignment. So main axis alignment would move all my elements on the x-axis or horizontally, but my cross-axis alignment moves everything on my y-axis or vertically. Cross-axis alignment. You pass in cross-axis alignment dot, let's try center. So center will change absolutely nothing because this is the default behavior for cross-axis alignment. You can do dot start. And when you do dot start, you'll notice that everything is aligned to the start of the row. So wherever this row is placed, it will align to the start of that. So it does not actually now align to the tallest item's center. You can type dot end, which would align it to the bottom of the tallest item.
Hello and welcome back. In the previous episodes, we learned how to arrange widgets horizontally using rows. But let's be honest, 99% of mobile apps are vertical experiences. We scroll down through news feeds, we look down at setting list, and we stack forms top to bottom. Today we're looking at the column widget. For a column, the main axis is vertical, so it's from top to bottom, and the cross axis is horizontal, from left to right. We're also going to tackle a new concept called responsive stacking. We'll learn how to tell a widget to take up all the remaining space using expanded widget, and we'll see the dreaded yellow and black error tape that appears when you run out of room. Now let's jump into code. I'm starting with a completely blank file today, so we can build our vertical layout from the ground up. Let's get our basic Flutter app structure in place with a column right in the middle. So you can skip this part if you've already got enough practice with this, which you should have at this point. But if you're still unsure, then just follow along with me. So the very first line, we import our package. So import our package, Flutter, material Dart. After importing it, we have to run our main function, void main. Inside our main function, run app, and we run a constant my app. All right, my app is our stateless widget. Oops, let me remove this space. It is a stateless widget that returns a scaffolding. Make sure you remove this const, otherwise you'll get an error. So it returns a scaffold, and inside the scaffold, we have a few properties. App bar, simply pass in app bar widget with, let's say, a title that's a constant text. So you want this constant because it improves your efficiency of your app, because it tells your app that it doesn't change. So your app doesn't look for changes. Let's just name it column layout. Then we have a body property, and inside body, I'm going to pass in a container. So container is basically like a box. You can have various settings and various properties to that box. Let me just give it a color. So colors dot gray. Let me give it a shade of 300. I can have a width. Let's just write double infinity. So an infinite width, and a height double dot infinity. So an infinite height. Containers always need to have a child, and inside our child, we'll finally use our column widget. So we've reached our column widget, and there are a few things that I mentioned at the start of the video. Similar to the row widget, you have main axis alignment, cross-axis alignment, and children. But in this case, the main axis is vertical. In rows, the main axis was horizontal. So let me start by main axis alignment. What are the few things that you can do? First of all, main axis alignment dot space evenly. It will make all the elements in the main axis space evenly. So vertically, everything will have equal spacing. Then we have cross-axis alignment. Let's say cross-axis alignment dot center. So everything will appear at the center of the screen, aligned with equal spacing vertically. The children. Now the children are the actual items that will appear on the screen. So I can have a container that's of the width 50, let's say of a height 50, and a color that's red. So colors dot red. All right. Now I want to have similar containers. So one container, two container, and three containers. Let me give them a different color each. So green and let's say blue. Let's make this a bit taller. So let's look at how this looks like in the app now. I'll be running it on my desktop itself, but if you have a phone attached, it'll show your phone like this, and you can simply click on the phone and it will run on your phone. Make sure your USB debugging is enabled. It seems like I forgot a small thing. Alright, Scaffold actually needs to be wrapped inside our Material app. Without our Material app, I've set up a standard Material app and a scaffold. Inside the body, I have a gray container filling the whole screen. So you can see this whole screen is slightly gray compared to the app part. Inside that, we have our column. So let me put this on top. All right. Inside that, we have our column. So this is our column. And it takes a list of children. So it has three elements or three widgets inside its children. And there are three different colored boxes. Red, a taller green one, and then a blue one. When we save, you can see exactly what the column does. It stacks our widgets vertically from top to bottom. So they're spaced evenly on the main axis. So on the y-axis, they're spaced evenly, and they're centered on the cross-axis. So on the cross-axis, they're centered. I have a question for you. What if you want to smudge these items to the top left corner of your screen with no spacing? Go ahead and pause the video and see if you can solve it. Okay, so the first thing we need to do is move this to the left. So instead of our cross-axis alignment being centered, let's move it to the left. So let's move it to the left by typing in start. Start, since this is the start, this is the end. All right, they're smushed against the left part of our screen. Now what about this even space? Simply remove space evenly and put in start here as well. Once you do this, you'll see them stacked on the top left corner of your screen smudged. Let's play with main axis alignment a bit more. Let's change it to end. What do you think will happen? It moves to the bottom of your screen. Let's change it to space between. So space between, and the middle one gets centered to the middle, and the top and the first and last gets centered. The first and last gets aligned to the top and bottom, or the start and end, and the middle one gets aligned to the center. Similarly, you can play around with your cross-axis alignment. There's also this funny property called stretch, which basically makes all of your elements stretch throughout the screen. It basically makes your children expand to fill the entire width of the screen. Notice that I didn't change the width of my containers. And even if I did change the width of my containers in this case, it would have absolutely no effect, since it's already stretching to the edges of the screen. Now let's go back to our normal alignment settings. So space evenly and center. Or actually, let's center both of these. Okay, so we have all our elements in the center in a column. Often in app design, you have a top bar, a bottom bar, and you want the middle section to fit all the remaining space. We need a special widget called expanded. Let's wrap this middle widget inside an expanded widget. So click on this action and click on wrap with widget and name the widget expanded. Wrap with widget and name it expanded. Expanded takes a child and the child is this container. I'm wrapping only the middle one in an expanded widget and I've completely removed its fixed height. So let me remove its fixed height. Let's see what happens. Even without a height, the green box grows to take up the entire middle of the screen. This is the magic. The expanded widget tells the column, calculate the size of the red box and calculate the size of the blue box. Then give all the leftover screen to the green box. This is how you build dynamic layouts like chat apps or social feeds that need to take up a certain space based on other elements. One final warning before we finish. Columns are not scrollable by default. So if you add too many elements, it will go over the screen and cause that overflow element. So in this case, let me just remove this expanded widget. All right, and let me save this. So we have our default. And let me create a bunch of containers inside the children of this column. If I add too many items to this column, let me change the color so that you can actually see the items. Green, red, red, red. All right. If I hit save or if I perform a hot reload, they still appear. But if I increase the height of these, you will see this, a yellow and black tape. It says bottom overflowed. It literally says a render flex overflowed by 594 pixels. This means that your content is too long. If you need a list that scrolls, you cannot use a plain column. You need something called a list view, which we will cover later. For now, remember that columns are for fixed content and not scrollable by default. Let's summarize the column. Column arranges widgets vertically, top to bottom. The main axis is vertical and the cross axis is horizontal. Expanded forces a child to fill all available remaining space, and columns do not scroll. If your content is too long, the app will warn you or show you a yellow and black tape. We have layouts down, we have text, images, rows, and columns. But our users still really can't do anything. They can't click. In the next episode, we're adding interactivity. We'll look at buttons and text fields. We'll learn how to capture tabs and inputs to trigger code. Alright, we're starting with a clean slate again. Because we're going to be capturing user input, we absolutely need a stateful widget. We've talked about stateless and stateful widgets before, but to simply put it, stateful widgets can change states throughout the application's lifetime, whereas stateless widgets remain constant throughout the app's lifetime. Let me create one called input screen. So at first, obviously we need to import our materials. Then we have our void main function that simply runs an app const called my app. This time around, my app will be a stateful widget. And inside our build method, I want to do a few things. So instead of returning a placeholder, I'll return a scaffold. So you have your app bar widget, app bar widget, inside which we will just have a title of a const, or you can have a const of a text that says interactive elements. All right, let's give it a background color this time. So background color, colors dot blue accent. All right. Then we have our body. Inside our body property, let me give a padding widget, and let me set a constant padding to edge insets all. So throughout towards every direction around it. Let me give it a value of 20. And our body needs to have a child. And inside our child, we'll add a column widget. We learned about columns in the last episode. So cross-axis alignment, we have a cross-axis alignment dot stretch. We covered this too. And let's have, and you need a children. I'm wrapping our main column in a padding widget, giving it 20 pixels of space all around, so our buttons don't touch the edges. I've also set the column's cross-axis alignment to stretch, so our input fields will fill the width of the screen, without us having to specify the specific widths of the input fields. First up, the most common button in Flutter that you will see is called the elevated button. So as soon as you type it, your IDE should automatically complete this. And we have two things. We have an onPress property and we have a child. The onPress function, which tells the app to do when tapped, and the child usually is a text widget displaying the label. And let me fill this out. So onPressed, for now, all I want to do is print to the console. So I simply want to print that an elevated button has been pressed. So it'll show an error because onPressed, inside the onPressed property, you actually need to pass an onPressed method like so, and then you put your print function in there. I need to have a semicolon at the end. Notice that your prints might be highlighted in yellow. That's because it's not recommended to have print statements in your production code, but for testing, it's perfectly fine. Inside your child, as I said, you usually have a label displaying what is supposed to be the button's label, basically. So it automatically gave me a text. I'll just accept the suggestion. So elevated button. What seems to be the error here? Right, the children needs to end with a big bracket. Oh, seems like I forgot material widget again. So remember, your scaffold needs to be wrapped inside material app, which has a home. I keep forgetting this. Okay. So you have your elevated button. As you can see, it is pretty self-explanatory. When you hover over it, it gives kind of a drop-down shadow effect. And if I click on it, so according to my functionality over here, when I click on it, it should print out elevated button has been pressed. And it does in the console right there. Done. Now let's add some spacing and look at the text button. So to add some spacing, right below our padding widget, actually inside our children, right after our elevated button. So this is sometimes hard to see, but you can see the labels here. It says elevated button here, so the next element probably goes in here. Okay. I want a sized box. So we talked about sized boxes before. It simply prints a space, if you want to understand it that way. So it prints an empty space of 20 pixels. Then I want to show you what a text button does. So text button is similar. It has two properties. One is the on pressed, and the other is a child. So your onPressed obviously still has a function. onPressed, still has a function. And inside the function, we just print text button has been pressed. And your child is again the label. So a text widget that simply just says something like text button. If we hot reload this, you'll get a text button widget. This is just much simpler. It takes the exact same parameters on pressed and child, but visually you can see it has no background color and no shadow, so it's much simpler. It'll do the exact same thing as the elevated button, but just the UI is different. Finally, we have our icon button. It's perfect for toolbars and small actions. So let's add another sized box. So that would be right below here. Okay, we'll add a sized box of height 20, and then we will add our icon button. Our icon button takes in a few extra things. So obviously it takes our on pressed because every single button has to do something when pressed, and it takes in our child, which is our label, but it doesn't take in a child because doesn't have a it doesn't have a label. It has an icon in place of a label. So it has a property called icon. Additionally, you can define another property called icon size, which let's set it to 40 for now. And obviously you have an icon color. So you don't actually type icon color, you just give it a color property and colors.red accent. On pressed, again, you pass in a function and you print not elevated icon button has been pressed. And in icons, Material Dart actually gives you a few default icons that you can play with. So you can just look around, but I'll use one here. You pass in the icon widget, and then you type icons dot one of these icons. So let me just pick one. Let's search favorite. Okay. Hot reload this, and you see this. If I click the elevated button, you'll see the corresponding one, text button corresponding one, and icon button also corresponding one. Icon button has a unique property. So instead of a label, it obviously has an icon. Tapping is great. You can tap all the buttons you want. They have animations and everything. But what if we want the user to type their name? For that, we need a text field. To read what a user types into a text field, we have to create a special variable called the text editing controller. We define this up at the top of our state class, so all the way up here. So just above this override statement, put in a few spaces and type in final. So this means that this value is not going to change. Text editing controller. And text editing controller is your data type or type of the variable that you're about to define. And the name of the variable, let's name it something like underscore name controller. And this will be a text editing controller widget. The controller will hook into our text field, so we'll pass in this controller into our text field and it will listen to every keystroke. Now let's go back down into our column right above our buttons and build the UI. Scroll all the way down and add this right at the top of columns children list above the elevated play button, above the elevated button. So right over here, let me put in some spaces. Right over here, I want to add a text field. And text field takes a few properties. Let me add in a comma right here. Okay. First is your controller. So the controller that we just created, we pass in here. Our controller was named name controller. Oh, I put it in the wrong space. You're supposed to put it right over here. Sorry. Our controller is our name controller. Then we have our decoration. So our decoration you can just give in a widget called input decoration, and you can have a label text. Obviously, inside the text box, you want a label. So your label text could be enter your name, okay? And you can have a border property. So outline input border. So if you want a border, then you add this property. If you don't want a border, then you can omit this property. Then we have something called prefix icon. So the icon that appears at the top or at the start of the text field. You'll see this when I actually run this program. So let me pass in a person icon. And at the end of this text field, before we start our elevated button, let's add a size box again of height 20. Perform a hot reload and you'll see this. So this border is because of this property right here. If you remove this property, then that border disappears. This icon or prefix icon is because of this property. If you remove it, then you won't have that prefix icon. And your label text is because of this property. So you can theoretically create a text field with just a controller and none of those properties. But it's not very interactive, is it? So that's why you can style it with different properties using input decoration widget. So you can see that arguably the most important thing here is the controller. It links our UI to our variable. That's all it does. This UI is linked to this variable right here. Inside the decoration property, we make it look nice. We add a label and outline border so it looks like a real input box, and a little person icon inside the box. When I tap it, if you're on your phone, then your keyboard will automatically pop up. But since I'm on my laptop, then it doesn't pop up. But I can actually type in here and delete the text. Now, how do we actually connect the data? To finish this off, let's connect our text field to our elevated button. When the user taps submit data, I want to grab whatever they type in here and print it out in the console. So on pressed on my elevated button, all I want to do is create a variable of the string type, typed name equals to, now we pass in our controller. So name controller, and this has a few methods. So .text will simply fetch in the text inside that controller that is linked to the UI. That's why we need a controller. So this controller has a bunch of properties. .text is one of those properties, which basically makes it so that whatever controller or whatever UI component this controller is linked to, it simply returns the text that is inside that component. Since this is linked to our input field right here, so if I do name controller.text, I will get whatever I typed in here. Now instead of printing the elevated button has been pressed, what I want to print is the typed name. Let's make this look a bit better with concatenation. So you can do this. The user's name is, use the $sign, and you use curly braces, and then you type in the variable name. So this will make it so that this piece of code or this piece of text is replaced by the value inside this variable. When you perform a hot reload, you will see visually no changes. Actually, let's remove this elevated button and let's change it to submit. Perform a hot reload, this button will turn to submit. Currently, if I press submit, it'll give me user's name is blank because I haven't typed in anything. But if I type in Coden, you will get the user's name is Coden, because currently in that box, the text is Coden, which gets stored in the name controller.text, and we're pulling it out and simply printing it out. And you've successfully bridged the gap between user input and backend logic. So you can send this logic to the backend, you can store this data somewhere, you can do whatever you want with it. You're successfully getting data back from your app where you're hosting it. Okay, let's start from scratch.
we'll import our material start, then we'll create our main function, and inside our main function, we'll run our app. We'll run a constant my app, and inside my app, this will be a stateless widget, my app, and instead of returning a placeholder, we'll actually return another widget. So we'll return something called, actually first we need to create a material app, and in the home of the material app, we'll return our input screen. Okay, input screen isn't defined right now, so we actually need to create it. And input screen will actually be a stateful widget because it changes state throughout the execution of the program. It doesn't actually just stay constant. Okay, so you'll create a stateful widget called input screen. Creating a stateful widget gives you two classes, and we've talked about this. So the first thing that you need to do is return a scaffold. Instead of a placeholder, we'll start by returning a scaffold. As soon as we do this, we'll get at least a white screen, hopefully. There we go. We at least got a white screen. So this white screen is actually run app running my app. My app calls input screen, and input screen returns a scaffold. Okay? Inside the scaffold, we want a few things. You want your app bar. Your app bar has a title. It has a text, let's say, that just says enter your name. And the background color is, let's just say something like colors.blue. Enter your name, colors.blue. I want this text to be white. So I'll simply do that by adding a text style widget and setting the color to colors.white. So it turned white. In the body, I want a padding widget first. And inside our padding widget, I want a constant padding of around everything. So edge inset dot all throughout. I want a 20 constant padding. If you perform a hot reload, you won't really see anything right now because we don't have any child. The child that we have passed is our column, and column in turn has a bunch of children. So all of the children of column will have the same padding that this padding is defined. Now we want a few things in our children. So what I want in the screen is a text field where you can type a name. Then I want a button that you can press to submit your name. And after you submit your name, I want it to move to a new screen that shows hello, your name. So that's the only thing that I want to do in this video. All right. The first thing that we need is a text field itself. The text field will have a property called controller. We'll look at what controller is. Let's leave it empty for now. Secondly, it will have a decoration. So decoration is a bunch of things. You have an input field, you have an input decoration widget, which will take a bunch of properties, like border. What do you want your border to look like will be defined by outline input border widget. So if you don't add this property, you simply won't get a border, and we'll look at how that looks like in a bit. Then we have label text is basically what will appear inside. Okay, and you actually don't need a text widget here. You can actually directly type the string. If we save it right now, we can omit the controller. If you save it right now, you'll get this. You'll get a your name, the text widget, and the padding that you see here is because of this padding. If I remove this padding, then this space actually gets smaller. And if I increase the padding, this space actually gets bigger because this input field is the actual one that gets the padding,
and not the text inside the input field. So the text inside the input field doesn't get the padding. That's this label text. The text field itself gets the padding. Okay, set this back to 10. It was 20, right? And you see the border, if I remove it, then it looks like this. So there's no border. Maybe you want your input field to look like this. If you want a border, then add this property, your input field would look like this. Now what does controller do? In your input field, you can actually type in a bunch of stuff and do whatever you want. But this data is not actually being read or stored by anything. That's where controller comes in. It actually reads all your data, stores it, it can perform operations on it, it can check if it's a number, string, whatever. You can do a bunch of stuff with it. So the first thing that you need to do when creating a controller is you go all the way to the top here. In your second class, it's a final variable. Final text editing controller. So this is the type. And I'll create a new controller called name controller. And I'll pass in text editing controller. So this is actually how you create a controller. This is the name of your controller. So simply come over here and pass it in. Uncomment this line, and you created your controller. You'll still see no visual difference, but the data that you type here can actually be used now. It can actually be accessed by your name controller. Let's look at how to do that. But before that, let's add a button that you can actually press to submit your name. Okay, so under text field, I want to add another widget. So inside our column, we have our text field first, and if I add anything, after that, it will appear on bottom, because on a column, it goes vertically downwards. Let's add a sized box. This is always a good practice. A size box of height 20. If you save this, you won't see a difference because size box doesn't have a color. But I'll add an elevated button after that, which takes in a few properties. So it takes in onPressed, which is a function that basically does something when pressed. And then you have your other property, which is a child. So your child property is just a placeholder text, right? Your placeholder text, let's just say submit data. If we save this, you'll get a submit data button right here, elevated button. If you actually decrease the size box height, it will get closer. If you increase the size box height, it will get further away. And your elevated button can obviously have style itself, elevated button, padding. Let's set it to edge insets all 20. So let's make the button a little bit bigger. Okay. And this text, actually, I would like to turn it white, but it actually looks good as is. It's a bit purplish hue. It looks good as is. But if I press this button, nothing happens currently because we haven't added functionality to the onPressed function here. What should happen when I press this button? Well, when I press this button, two things should happen. First, I should get the name that is stored in the text controller here. Second, I should get a new screen that says hello name. So let's tackle the first problem first. How do I get the name that was typed here? The way we do that is simply just create a string and create a variable called typed name. And the value of that variable is simply name controller dot text. So dot text simply goes into the name controller. So the dot text simply goes inside the name controller and then looks at whatever was typed here and then gets it, stores it in type name. Next, the second issue. Now we have the name. It's stored in the type name variable. I want to create a new screen.
And in the new screen, I wanted to say hello name. So the way you create a new screen is you push things onto the screen. So the way you push things onto the screen is using navigator. Navigator.push. Navigator.push requires two things. First is the context, and second is the material page route where you're pushing onto. What is the context? The context is an object that has all the information on where you are in the screen right now. So context has the information that says we are in input screen. So we're in the input screen class, the context knows that. If you pass in the context here, it would know that you are in my app. So we're basically passing on the context, which basically says, hey, you've been called from here, or hey, this was on the screen before you were called. So after you're done, this should be on the screen. Below context, we give in a material page route, and we point it to the page we want to go to by using a builder property. So you pass in the context, you create an arrow function, and let's say welcome. Now it'll actually show an error on welcome screen because we haven't defined it. Welcome screen will simply be a stateless widget because welcome screen never changes, right? So once you get this type name, it never changes, so we'll create a stateless widget. And inside welcome screen, all we do is return a scaffold. And I don't actually want to make an app bar for this. So if you want to create an app bar, you go ahead, but I'll simply directly create a body. And inside the body, I'll center a column. Inside the column widget, I'll align it to the center. And its children will have a text that simply just says, hello, typed name, exclamation point. You can add some styling if you want, you can do extra stuff, but I don't really want to do all of that. What do you think happens if you run it right now? Well, as you can see from the program itself, it gives you an error. It's highlighting the type name in a red. But we do have type name declared here. See, you have type name right here, and then you're calling welcome screen inside that block. Then why is it that type name isn't defined here? Well, that's because every screen or every class has its own independent set of variables. Once the control has been passed on to welcome screen, all the variables that are not necessary aren't loaded on to that screen. So type name isn't actually passed on to welcome screen. Input screen knows what typed name is, but welcome screen has no idea what type name is. The way you pass it is when you push this widget onto the screen, you actually pass it like so. So user name, typed name. Now you'll get an error under username saying that username hasn't been defined yet. That's because you're not actually accepting this variable in your welcome screen yet. So inside your welcome screen, you need to create a final variable before your override or your build function. So you start with final string username. Once you do this, you'll get another error in the constructor of your class. So this is your constructor. You'll get an error saying that this variable isn't initialized. What that simply means is that you haven't passed required this dot user. So whenever a class is called, a few things are necessary. First, the constructor function runs. So when the constructor function runs, it runs super.key, which basically means every variable that needs to be initialized from the stateless widget is initialized. But our welcome screen takes in a variable of its own, called username. So this username must also be initialized, and it must be a required initialization. This means that every time this class is called, it must be required to send a username. So once this username is sent, we store it in the final string, username, and instead of type name, we can finally use username over here. Okay? And when we're calling, or when we're pushing this onto the screen using navigator.push, we use welcome screen, and we pass in the name of the variable that's accepting it, and we pass in the name of the variable that we're sending. So you don't need braces. Okay. This should be completely working now. If you perform a hard reload, in your name, if you type in coded and submit your data, it says hello coded. But as you can see, we have no way of actually getting back to our original screen now. If you added an app bar here, you'd probably get a back arrow here given to you by Flutter by default. So before going back to the screen that we were previously, you have to understand how these screens work. So if you're stuck here, all you need to do is simply pull this up and perform a hard restart. Then you go back to your screen. But you need to understand how Flutter works with different screens. It works by pushing things onto the screen or popping things off the screen. Pushing something onto the screen means that you're adding a new menu on top of a menu. Right now, when we navigate or push, it basically puts this welcome screen widget on top of what we already have. Underneath, this widget still exists. Now simply to view this widget again, we can simply pop this off. So we added this on top. If we remove it from the top, we can view this screen again. So simply to move it off the top, we use something called navigator.pop. Now let's add a back button and test how that looks like. So to add a button, and we've seen this before, we have our... So I'll simply add a button, okay? After we have this text that says hello, we'll add a text button, and which has an on pressed property, and your on pressed property takes in a function. The other thing that it takes in is a child. A child could just be something, a text that says go back, and that's it. Now the question is what we want to do when on pressed. So as I said before, simply just navigator.pop, and we give in our context. And this is all we need to do. So perform a hard reload, give in your name, click on submit data, you get to this screen, and you have a simple text button here that says go back. When you click on it, it pops your screen off. When you click submit data, it pops your screen on. When you go back, it pops your screen off. I've deleted absolutely everything in my main Dart file, once again and for the last time. We're starting from scratch. First, we need our standard Flutter imports and our main function to run the app. So we've done this about 100 times now. You should be very fluent at this. Simply, at the very beginning, import your materials, then your main function, and you run app. Constant, let's call this a business card app, but to do that, first of all, you need to run a my app. So this is the proper practice for this. We didn't do this in the previous episode, but this is how you're actually supposed to code in an actual application. So you run my app. My app is a stateless widget. And my app, instead of returning a placeholder, actually returns a material app whose home is actually, let's say, business card app. All right. Oh, you don't need this. Okay. And our business card app was created here. Stateless business card app. All right. So what we're basically doing is we run my app, and my app sets up material app for us. And in material app, we're simply just calling business card app. And we're defining business card app somewhere else so that our my app is clean. Okay?
Inside our business card app, we don't have to define material app again. We can directly start defining our scaffold. Okay. So we'll create a scaffold and let's give it a few properties like background color. And let's give it colors.teal, something new for a change. And let's give it a body. We'll pass in something called safe area. And safe area has a few properties. So we'll pass in a child and we'll pass in a column. So we've learned about columns in previous episodes. So we have a main axis alignment. Let's align this to the center. And our column has children, of course. I've used a teal background color and I wrapped our column in a safe area widget. Okay, so this is a great trick to ensure that our content doesn't actually get pushed up in the phone's notch or status bar. So if I have a lot of content, it basically makes sure that the safe area, so safe area means where you're showing your battery or where your time shows. So you want to make sure that none of your content gets smudged against your time or notifications or anything like that. So safe area, make sure that doesn't happen. It takes a child and we're just passing in a column with a bunch of other elements inside it in its children property. Okay, now let's add the first thing inside its children. Let's add a circle avatar. So it's exactly what you think it is. So a circle avatar widget, and it takes in a few properties. Radius, let's give it something like 50.0, and let's give it a background image. Let's look at what images assets we have over here. So we have an asset called logo. Oh, it's just a Flutter logo that I've used. So let me just give it that. The way you do that is asset image and simply given the path. So dot slash assets images logo dot png. Okay, that should hopefully point to the right path. And of course, make sure that you have it imported in your pubspec YAML file. We've gone through this before, but I'll quickly go through it again. Yes, it is an imported asset, so it will work. Make sure the path actually matches whatever image you actually have in your project. Let's start this application. Okay, it seems like the asset wasn't actually loaded. Oh, seems like simply I just misplaced this slash over here. Okay, perform a hot reload. Actually, I think we need to perform a hot restart. So close your app, run it again. Okay, so we have a circle, as you can see. In the main axis, it's aligned to the center. Remember, your main axis is your vertical axis for your column. And in our children, we just have a circle avatar, which is this. Inside our circle avatar, we have a background image of this asset. And the radius of this circle is 50. So I probably want to increase this by a little bit because, okay, never mind. Oh, it has a pretty cool animation when it changes. That's nice. Let's add a name and a job title. So this is my business card logo. Let's add a name and a job title. So I just want to make this using standard text widgets and styling them exactly how we learned how to style in previous episodes. So, comma, text widget. Inside our text widget, let's add something like coding developer. Okay, and give it a style property and text style widget. Inside our text style widget, let's change the font size. Let's set it to 40. Let's hard reload this. Let's see how it looks. Okay, it looks pretty nice, but I want to change the color. So colors dot
white looks better. And I think it would look better bold. So font weight is bold. Okay, code in developer. Next, let's add another text. So another text widget. Oops, you have to be outside the text. Text widget. And let's say, oops, I need a comma. Flutter engineer. Okay, now this will obviously appear below my code in developer because this is in a column. Okay, there we go, Flutter engineer. Now I also want to style this. Let me style it. And text style widget. So you have the basic idea of what's going on here. We're basically adding stuff to the bottom, we're adding text like we want it, and we just keep on styling. Okay, text style. Let's change the color to something like color .teal .shade 100. Let's see how that looks. Okay, and let me reduce the font. Let me increase the font size a little bit. And the spacing isn't that much, so like there isn't a lot of spacing here. I want it to be a little bit spaced out. So for that, we have a property called letter spacing, and I can give a value like 2.5. You can play around with the values to your liking, but I'm just using standard values here. And obviously, I also want this to be bold. So font weight dot bold. Okay, looks good. Now, to separate our header from our contact info, I'm going to drop in a sized box and a divider widget. So what a divider widget is, it's a widget that simply just draws a line. Let's do this. I want to draw a line right over here. So I'll press enter here. And let me add a sized box first. So there needs to be a space and then the divider line. To add sized box, simply just create the sized box widget. Oops, again, outside your text. Make sure you add a comma. Outside your text, add a sized box widget. And remember what sized box takes. It takes in a height and it takes in a width. So height of 20.0. All right. Now, obviously, you won't see a change because sized box is actually transparent. But if I add anything below this, actually, you can add the divider inside the sized box itself using a property called child and just add a divider. And sure, we'll take in that suggestion. If we save it, you see a small divider after a 20 pixel gap, and this will also have a 20 pixel gap on the bottom. Okay? Now for the contact information. What we want is we want a white box on the left and a text on the right. What does that sound? Pause the video and let me know what I could possibly use to make an object like that. So I want a box on the left with an icon and text on the right. That's right, it sounds like a perfect job for container and a row. So I'll create a container. Inside the container, I'll put in a row, and I can put two things side by side. Now you can have rows inside columns, you can have columns inside rows, you can have containers inside rows and containers inside columns. So Flutter is actually pretty flexible in this case. So I'll simply start by creating a container. Container, I want a margin. So margin is, remember, padding is the space inside and margin is the space outside. So I'll create a margin and edge insets. I don't want all, I want a symmetric inset. So symmetric means I can give a vertical value, so above and below what I want, 10.0, and a horizontal value, so left to right is 25. I want a padding too, actually, which is adds insets all. Just give it 10.0. Actually, let's give it 15.0. A container can have decoration. So remember how we did this, and it takes in a widget called box decoration. Let's change its color to colors.white. Let's see how this looks right now. Okay, it looks like this right now. Let's add in a border radius. So I want a circular border with a radius of 10. So I basically rounded this a little bit. And that's all I want with the box decoration. Okay. Next, I want a child. So a child for the container. And the child is actually, how we discussed, it's a row. So the child inside the container is a row. So you have a bunch of things inside this. The first thing that I want inside the row is my children property. And the first thing I want is an icon. So icons.phone. I can give it a color, simply colors.teal. How does that look? Okay, I have an icon, phone icon here that's the similar colors to my background. Next, I want a sized box of just a width. I don't want a height, a width of 20.0. So what would this size box do? It adds in a space right over here. So if I save it, you can't see anything, but there's a size box of 20 width here. Next, we'll add in a text with our actual phone number. So text, let's give it a phone number like +977 1 2 3 4 5 6 7 8 9 10. Now that's actually a random number. Please don't call that number. I have no idea whose number that might be. So there we go. And obviously we can give it styling, which we will appropriately. Text style, color, colors.teal.shade. Let's use shade 900 this time. I want a font size too, so I'll increase the font size just by a little bit, not by much, just up to 18. Why is this showing an error? Okay, I put in 9,000. And look, we see our phone number. So let's break this down. The container handles the white background, the rounded corners, and the margin on the outside. So this space, and the space on the right here is handled by the container. It also handles the padding that is inside. So if I reduce the padding of the container, if I give it suppose something like 2, you'll see that this gets smaller. 15 looks much better, right? The row inside the container lays all of our foundation. So the row lays in our phone and our phone number. I used a size box for this gap in between them, and you can either use a margin or a padding. You can also just wrap this text inside a margin or a padding, but using a size box is much more efficient. For the email card, what I'm going to do now is simply just copy this entire container block and then paste it. So since this container block is actually inside our column, so this will appear below this container block. It'll look exactly the same, but I'll just change this to give something like info at
student.com, and instead of the icon being an icon for a phone, this icon will be icons.email. There we go. You can edit this to your liking. You can add more stuff. You can move this around. You can change this padding. You can change the vertical alignment, the horizontal alignment. For example, if I wanted everything to be smushed to the top, what would I do? Well, you have to understand the layout first. All of this is wrapped in a column first. Well, at first it's wrapped in a safe area, which basically means it won't interact with, it won't overlap your notification bar. Inside it, you have your column. So in your column, the first thing that you have is this avatar. Then you have this text that says code and developer. Then you have this text that says Flutter engineer. You have a small sized box here with a divider inside it. Then you have another container and another container. So that's your column. Inside these two containers, you have a row. So inside the row, you have a phone, you have a small sized box, and then you have a number. Inside this container, you have an email, a small sized box, and your email. So if I wanted to move everything to the very top, what would I be editing? Would I be editing this container? Would I be editing this text? Would I be editing this size box? No, I would simply just edit the column. So I come here, I come to my main axis alignment, and instead of center, I do start. So don't use something like top or end, because that's not what we use in Flutter. We use start or end, okay? So start is the top, end is the bottom. In the case of row, start is your leftmost and end is your rightmost. If I hot reload this, then everything is mushed to the top. If I center this back, everything is towards the center. If I want to space it evenly, I have space evenly, which will space it evenly. So you can change your UI like this. You can move stuff around. You can make these boxes shorter by simply changing your containers. So if I come into my container, I have a horizontal property that I can simply change. Sorry. If I come into my container, I have a horizontal property that I can simply change, increase, because this is set to the middle. I can set it to the left, I can set it to the right, I can align it to my liking. So if you put in too much of a big value here, the render will overflow like this. So you don't want to see that, put in a normal value. I actually like how 450 looks like, so I'll change this all to 450. I actually like how that looks. And I want to center this, so I'm wondering what I have to do to center this. This would be a row. This would be my container, and all the elements are inside a row. So I'm thinking I have to wrap the row in a widget, and this widget should be a center widget. So this should theoretically center my entire row and bring it to the center. Okay, so that didn't work. So we have an alternative. So let me just undo what I just did. The row also has a main axis alignment, right? Your main axis alignment. So what is the main axis in the row? It's horizontal. So this is your main axis. Currently, it is smushed to the left. I can just center this using main axis alignment dot center. Now this should probably bring it to the center. There we go. And I'd like to do the same for my other row. Oops, not inside the children, inside the row itself. There we go. Both of those are centered. You can add more cards, you can put your photo here, you can add a bunch of stuff in the background. Tweak with the design to your liking. Now for the final thing, I want to add a button at the bottom that uses the navigator we learned about in the last episode to open a Hire Me screen. So we learned about a few buttons, right? Which button am I going to use? Well, you can use any, but I will be using the elevated button. So at the bottom of our last object or our last widget in this column, it's this container. So this container right here. Below this container, firstly, I'd like to add a sized box. So a sized box of height 30, let's say. I want a big gap. And then elevated button. We talked about this in the previous episode, so your memory should still be fresh. OnPress takes a function. And inside this function, we simply just want to navigator push, right? Navigator.push. What are the two things that this requires? One is your context. Context basically has the information of where we are on the screen right now. And the next thing that it requires is material page route. And we need to point to our widget. So our widget, point to your widget like so. Now currently I'm saying our widget is this hire me screen, but it's not defined, hence you get this error. This will show an error because hire me screen doesn't exist yet. For that, create another stateless widget and call it hire me screen. Now currently we're creating all of our stateless and stateful widgets. In the same main.file, file, but in actual app development, you generally don't want to do this because you likely have 100 different screens with thousands of functionalities, and having it all right here in the main file can be confusing and it can be a lot to debug. So you'll essentially divide this into folder structures that are easier to manage. In this series, we're just looking at the basics of Flutter, so we won't go to that detail. But if you want to learn more about that, I'll make sure to make a series or a full project type of video where I utilize everything that we've learned in this series, plus more to make a fully working weather app or anything of that sorts. Okay, so we have our Hire Me screen. So whenever I push this elevated button, oops, the child, okay. The child, if you remember, is just its text or its label. In the label, let me just put in hire me. So currently, this looks very plain, very basic. Let's make this button a bit more visually appealing. So in our elevated button, you can have a property called style, and you have elevated button dot, oops, that's not it, elevated button dot style from, and you can add a few properties. So you can add a few properties to the elevated button itself. Let me change the background color to colors.black87. Background filter, background color. Okay. And let me change the padding, so the space around inside the button, to edge insets symmetric, sure. Vertical, let's say I just want 15, and horizontal, let's say I want around 40. How does this look right now? Looks a bit better, but the text inside is still some weird color. So let's change the text styling. Simply just put in a style property here, and let's change the color by textstyle.color colors.white. And what did it add? It added a font size. I don't need a font size. I'll just remove this. I need one more small bracket here. Okay. That looks much cleaner. Okay, when I click on it, I actually get redirected to the Hire Me screen. But since we haven't made a Hire Me screen yet, it shows this black cross. Let me just, I don't think a hard refresh will prevent this from happening again. Let me just perform a hard restart. Restarts the application. So if you navigate to a screen that hasn't been built yet, that's what you'll get. That's what the placeholder actually returns. Inside this, you actually want a scaffold. So let me create a scaffold here. And you've done this a few times already. Scaffold has a few things. An app bar. Simply pass in an app bar widget. Give it a title. Let's give it a text widget that says, let's work together. I'm sorry if you can hear the dogs barking in the background. I'll try to remove it as much as possible, but you still might hear a faint barking sound. Okay, so colors.teal shade 900. So we've done this a few times already. We can actually reload this, and instead of going to our business card app by default, you can actually set the home to be our Hire Me screen temporarily while we're testing this. So each time you don't have to press this button or like go to a different menu. When you're testing out different screens or when you're testing out different widgets or classes, you can simply do this. So you can simply set your home to the class you want to test. If I perform a hard reload, you can see that we automatically go to that screen. This title does say let's work together, but I don't really like that it's red. I don't really like that it's black because I really can't see anything. So let me put in a style, text style, color, colors.white. Okay, I can read that much better, right? I also want to center this. I don't really like how it's right on the left. So I'll wrap it in a center widget. Simple as that. And it's in the center now. Good. After our app bar, we need a body, obviously. And our body, I'll pass in a center widget again. And in the child, I'll pass in a text widget. So in our text widget, let's just see something generic like thank you for reviewing my profile. And let's give it some styling. Text style. Let's increase its font size a little bit. So font size, let's give it something like 25, sure. And let's give it that color. Let's see how this looks. Thank you for reviewing my profile. It looks great. Now let's run through the entire application. Let me remove the Hire Me screen, and instead of that, let's start with the business card app. And perform a hard reload or a hard restart. You have your business card, you have all the information here. Obviously, you can put these to text fields, or you can put this, you can add a contact me button with a text field that takes in an email and then prints it out in the console or saves it somewhere. And we will be learning how to use APIs, how to call APIs, and potentially even create a full stack application where you can add and remove stuff and retrieve stuff from databases. So if you want to see a full project made with Flutter, please make sure to comment and let me know what kind of project you want to see. I'll be more than eager to use all of the knowledge that you've gained throughout this video, plus more to create a full stack project. Okay, so you have this Hire Me button. You can click this Hire Me button and you'll get this, thank you for reviewing my profile.
So for a split second, you saw the background and you saw this pop up on top. So that's essentially what navigator.push does. It puts this on top. Okay. We can see this back button that automatically appears on the app bar. So this is just an automatic feature given by Flutter. When you click on back, all it does is the screen that you just saw gets popped off. So pushed on and popped off. Pushed on, popped off. And it gives you a small transition like animation too.
You, learning a new framework is not easy. It takes patience to deal with errors, red screens, and complex layouts. But you stuck with it. You now possess the foundational skills to build front end of almost any mobile app. So what is your next step? To take your skills from the beginner level to the intermediate level, you should look into these three things. Advanced state management, where you learn tools like Provider, Riverpod, or Block to handle data in large apps. Networking and APIs, and backend integration. I'm incredibly proud of what we've built over these 14 episodes. Keep practicing, keep building, and don't stop coding. Thank you so much for watching the series, and I will see you in the next one. I want to personally congratulate